If you hear this message, that means I was able to break time continuum and reach out to you. I'm in year 2055. Robots are everywhere. They drawing pictures and writing poems while people do dishes and house cleanings. What a mess. And one more thing. All the robots are running on Java. This is incredible. I love it. No, now I need to travel back to 2025 and inform everyone there. This won't be easy, but I need to try. I hope that there is Java and it's still on. Hello everyone. Welcome to Java On 2025. I'm glad you are with us. I'm glad we're starting one more conference. Thank you very much for being with us, and thank you for being our audience. So we have nice agenda today, and this is our fifth conference, by the way, guys. So 5 years straight in a row we do this conference, and I do hope you love it, and I do hope that we bring useful information for you, and each year we're here for you. So also this year is not just a regular year, right? This is 30th jubilee of Java. 30 years ago, Java was created as a language, and I hope that we all are fans of this language still. We all use it every day. Maybe it's brothers and sisters, I would call so. So yeah, that's why we're here. That's why we celebrate Java, and that's why we do this conference 1 year more. So as always, we are here on YouTube and on We Are Community platform, and we broadcast it for all of you. So I already see that some people are writing messages in both chats. So please tell me that you can hear me, that you can see me. Yeah, hi everyone. I see your messages in both chats as always, and I will read both of them through the conference. So let's start with small presentation. So let me tell you on what we have today. So this is Java On 2025, and our motto for this year is nostalgic for the future. So we look into the future, but also looking back and try to understand what was these 30 years and how was it for all of us. So this conference brought to you by two communities, is Jacob and Minik. We really worked hard to make this conference happen. So huge kudos to everyone. I will show the pictures a bit later. Also, I want to say thank you to our partners. It's We Are Community platform. It's of course EPAM, JetBrains, and Community Binary Brains. Thanks for our partners and sponsors to help us making this conference happen. Also, these are our partner communities. Here are all their logos. Thank you guys very much for your information with your help with information and everything you make for us. Thank you very much. And also tomorrow there will be some rewatching of our conference offline at some offices. I will show it a bit later. But before, I need to show all these faces. So this is Java On team. Everyone is here. They are amazing. They do this conference every year, and I love all these guys. So they are just awesome people. And if you know them, write them into some message like, hey, I saw you're in Java On team. I love this conference. Thank you very much. So today we have only one day. We decided to make this conference short but full of interesting topics. We have 6 speakers in and 5 locations. We'll have their offline events with us today. Actually, it's 6. Yeah, we have small increase just yesterday. These are our today's speakers. You will see all of them today into our conference. Yeah, I will not go through all of them right now, as we just jump into the conference and you will see all of them. And these are our offline events. They are not all happening today. Some of them will happen tomorrow. So these are for EPAMers only. So if you are EPAMer by any chance, and if you are in this location, please check your opportunity to join these offline events. Guys prepare some really interesting stuff there. They will watch or rewatch our talks from today, and also they have some local talks to do so. And I hope they all have some food as well. So if you're starving, please consider joining these events. And here you can see the community communities which make these events happen. So huge kudos and hello to all of them if they listening to us. And if you listen, please write something to the chat, please. Also, today we have a special retro quiz, and here is the QR code. You can join it through it. We also will send a link to Kahoot several times through the conference. So please join it. You have opportunity to win IntelliJ licenses. We have several for you, so please participate in this quiz, and after the conference we will contact the winners and tell them that they are winners, of course. Yeah, some obvious stuff, and give away their licenses. And basically couple rules before we start the conference, guys, and this is a huge ask for me. I will probably repeat it several times for the conference. So first thing is that your questions are highly appreciated. So please raise your hand by sending message in the chat, and put your messages, your questions to our speakers in the chat. And with this, we can understand that you are listening to us and you're interested in the topics we are sharing with you. So please write the questions. I will monitor both chats as always on VR Community Platform and on YouTube. So both chats will send me questions, and I will forward them to our speakers to gain more knowledge from them. Also, please, this is an ask from me. I do understand that we are in this online mode for quite a while, right? And we cannot fight with this hesitation, right? With this mania to do multitasking. So this is an ask from my side. Please don't. Let's dive into the conference. We try to do this interesting for you. So please, if topic is interesting for you, just turn off all notifications and try to be with us, be with this topic, and not to multitask. I know how it is, and I know how it's hard to come back from the project, from your tasks, and come back to the conference. So yeah, if you are with us, please be with us. You can always rewatch, you can repeat and move forward. So this is for you. Please use this opportunity. And also, we ask you to rate our speakers. So in VR Community Platform, they are stars, and you can punch them. You can go there and rate all our speakers. This is really important to receive the direct feedback from you, for us, for our speakers, for everyone. So please don't forget to put your rating there. Of course, I cannot say that you should put 5 stars for everyone, but please rate. let's put it this way. Don't forget to put a rating for our speakers. And yeah, that's mostly it. Welcome to Java On. This is QR code to VR Community page if you are not there yet. So all information, all our agenda, everything is there. So you can find all information there. So with this, we are ready to start our conference. And just to begin, I want to invite to me here on the stage the head of Java Competency Center at EPAM, Evgen Greskov. Evgen, welcome to Java On Conference.
Hi, Roma. Hi, everybody. Thanks for actually letting me this exciting opportunity to speak to you guys. Perfect event, like formally or recently, only 4 times. A bit excited being a part of this 5th anniversary event, let's say. And by the way, next year, Java On gonna go to school. I just
That's
realized.
True.
Actually, I just realized that I am with Java since 2001, I guess. So Java been 6 years old or 5 years old when I have started. Exciting intro, and actually, I guess all the things that are being discussed today, all the messages that are going to be sent, let's say, and all the talks are actually sort of pretty close to the very first seconds of the opening. By the way, Roma, nice glasses. I really
Thank you. Thank you very much.
So I'm pretty sure that everybody will try to answer this tricky question as of today. I mean, where we are, who is the engineer of our future, or the future engineer, and how Java goes there. Like in my universe, and I guess same in yours, there is no future without Java. Like whoever can speak about whatever, Python, Kotlin, whatever else. I guess I'm not going to be banned here for spelling these 2 words at least, but I'm going to stop. Anyways, I cannot imagine the future without Java, so as I cannot imagine the future without everything related to AI and sort of robotic stuff. So we live in the perfect time for the advancing, for making the new stuff, for building new approaches, going to new levels, to never seen before, to the levels of services and of engineering and of development that they have never seen before. I'm a bit concerned about the picture you've shown us recently, and I guess it's been done in parallel reality, sort of. But I'm pretty sure that in 2055 we will live hand by hand with, let's call it robots, with assistants, but still not really sure that we're going to serve them. All in all, 30 years already done by the technology. I am sure that much more years about to be done and are waiting for us in future. I would like to say that I know this future for sure, but unfortunately I'm not. But I hope that all the talks today will bring us some clarity and show us the direction for the next steps both technology and the industry gonna follow.
Okay, wonderful. Thank you very much. Yeah, I do hope that it's not my picture, by the way. It's Roma from the future. So I do hope that we can change the future. And yeah, if you remember this classic film, Back to the future is not like built in the stone, so we can change that. So thank you very much again. Thank you very much for this introduction, and have a great conference. Oh, by the way, before we proceed, so a couple of questions from my side. So as we're moving to this AI world, and as we're moving to this AI adoption, what maybe you can give some advice to all Java engineers, what they can do, what they can learn, and how they can prepare themselves for this future.
You know what? I would say that my advice is keep doing what we have done or what they have done already. I mean, in this world, there are no engineers who is not developing themselves, who are not developing themselves. I'm too old to remember Java 1.1 or 1.2, and I've seen a bunch of revolutions in engineering. Like, you probably remember how excited we've been when we got Eclipse out of Borland J++, or when we got an idea, when we got some sort of assistance there. Somebody was writing their own plugins for Eclipse to get the assistance. And all these steps every time made our life much easier, made the development much more productive, and the developers much more happy, let's say. Not spending lots of time on some boring stuff and focusing only on the cutting edge things, on the stuff they want to. So on my end, it looks like to be successful in the world, in upcoming world of AI assistants, the engineer have to do exactly what they were doing earlier. I mean, develop themselves all the time, never stop looking for the new things, and actually do as much as they could to do less.
Okay. That's great answer. So another question. So we move into AI, right? But we're still Java engineers, and we still need to be great engineers, as we should be some role models for everyone. So maybe you can name top 3 skills making us true Java engineers, in your opinion.
It's a tricky question. You should have sent it to me during the session. First, like it's hard for me. It's hard to answer these questions in terms of Java engineering. Like the first skill is never been out of curiosity. I mean, always be curious about whatever you see, whatever you want, whatever you can touch. Just if you can touch something, just touch it. If you can try something, just try it. Be curious about this. The second skill is always be as lazy as you can. Like, again, if you can do more with less, do it. If you can spend, I don't know, a day to build the assistant that will save you half a day after that, go for it. Like, be lazy, but in productive way, let's say. I hate this word, productivity, but let it be so. And the third thing, or that the engineer should be in touch with, is focusing on how the things were done already. With every step in every evolution, we always have the changing environment, but it's always placed on kind of the same rules, or on kind of, let's say, classic way, even with the new technologies, even with the new assistants, with whatever else. So like, you need to know how the things were done earlier to make them better in future.
Okay. And the last question before we let you go. So Roma from Future tells us that in 2055, Java is there and all robots runs on Java. So in your opinion, is it true?
You know what? Yes, I think that it could be so. Like, I love Java. I'm a Java guy. So let it be so. Let it be the best future I can imagine.
Okay, thank you very much. This was Evgen Griskov, head of Java Community Center. Evgen, thank you very much for joining us. Thank you for your intro words, and have a great conference. Thank you very much.
Thank you, guys. Thanks, Roma. Bye.
Okay, we are continuing, and before we proceed to talks, we have a really nice, let's call it historical activation to have a look back into Java history. And I want to welcome here on the stage my colleagues and my core orgs from the team, Tanya and Nastya. Welcome to the Java On.
Yeah, hello everyone, and nice to see all of you here today. Special greetings from the Miniki community, by the way. So today, on behalf of our teeny tiny community, we've prepared a teeny tiny set of interesting facts for you guys. But first, let me remind you that as Roma has already shared, and as you have already probably seen in the chat, today we're organizing the quiz, which actually is available on the background of our conference. You can actually play it while listening, but let me remind you the Roma's rule, do not multitask too much, so let's use the breaks for that. And actually, we would like first to give you a chance to remind or remember or just study some new facts from the history of Java language, since we're in a kind of nostalgic mood. And I think that in order to do this, my co-host and amazing colleague, our today archaeologist of Java, Anastasia, will share some interesting facts from the history of the language with you. So I would like to give a word to Anastasia, and let's begin with our first fact.
Before we start,
hello everyone.
Thank you very much. Before we start, I just want to say that guys, this is a big pleasure for me that I'm like here like a speaking head for like all these years, and that's really great for me when people from org team also joins me here, because it's like it's not only me here. We're the team. We do this conference. So yeah, thank you very much for doing this, and yeah, let's have a look on these Java facts. Yeah, Nastya, where's the floor to you?
Okay, thank you for warm words. And today I'm going to be like I don't know, storyteller reader or maybe fairy tale reader. And let's start from the first fact that we found for you. Star 7 prototype. On September 4 in 1992 year, it's quite far, as you see, the green team completed work on the prototype and demonstrated the Star 7 gadget. During the presentation of the Java language, it was a small device with a 16-bit LCD display. There were no button interaction with the user, was carried out via touch screen. Even turning on the device only required touching the screen. Actually, I think for now it's just our simple real life and the daily basis stuff. I think we always use touchpads and do not realize our life without it. I don't know.
Yep. Actually, that's really interesting how Java forecasted the future in terms of the actual meaning of the language and how exactly the project in general was built around this prototype gadget device, which should allow to manage different kind of IoT originally, as far as I remember, but it was the first touchscreen prototype, and it's a bit sad that history has moved in a different direction, and all of that evolution of the language as well as evolution of the technologies has moved a bit more to the internet era rather than to the devices. Possibly we might have had some earlier prototypes of LCD displays in zeros or tenths, but not later. So actually, I think that this is great opportunity for the for the developers who are thinking wider than the regular tasks and would like to experiment. This should be the inspiration to experiment, even in case if you're ahead of time. Rom, how do you think?
Yeah, I try to remember the year when real devices came on the market. I mean, with touchscreen. So, guys, if you remember, let us know in the chat. I think it was somewhere 2004, 2005. So iPhone was released in 2007.
It depends, yeah.
So iPhone was released in 2007. It's definitely, but before that there were devices with, less responsive screens. Let's call this that way. So I think it's 2004. So it's 8 years, let's say 8 to 10 years before the first prototype and the real usage. Yeah, that's nice to have in the in mind when we speak about new technologies. Even nowadays, that sometimes between prototype and the real use case for everyone, it's it needs time to pass.
And Java was behind of all of that, which is amazing.
It's pleasant to realize that you're working with Java, and it's just fundamental stuff which helps us to live in our modern world.
Yeah, that's true.
So let's jump to the next fact then.
Yeah, just simple fact, J++, and do not confuse it with C++. It's exactly J++. It was Microsoft's own version of Java, which runs on the proprietary JVM, MJVM. J++ was introduced in 1996, but its support ended in 2004 due to legal disputes between Microsoft and Sun Microsystems. As well as Microsoft's shift toward developing C# and J#. This language and MJVM were designed to run Java application on Windows with additional instructions and functionality.
So, again, about the interesting ways of how the language could have been or might have been growing, development itself in different directions, variations, and all of that stuff. So basically, currently we have quite a lot of languages which are JVM based, and there are a lot of options where and how you can find write on them, how you can run them. There are a lot of different variations in that direction, but it's important to note that definitely not all of them are currently like alive, let's say. So the evolution, which will be actually a part of my presentation, teeny tiny spoiler. So I'm gonna tell you guys a bit more today about in general, this option of evolution, let's say. So basically, evolution in removal is also important in order to find and leave the best, the most easily supported, easily used, the most convenient, the most supported by the community stuff. So that's, I think, how the languages have been developed and how they will be developed around our beloved JVM. So, Roma, any thoughts from you? But by the way, could you, Roma, also guide us through the comments in the chat? I see that guys have already posted some interesting
stuff. We have a comment from Alexei that he used to run some Java apps on Siemens SXG75, which even didn't have touchscreen. I think I will share a comment from myself about Java a bit later. But regarding this fact and J++, I think somewhere in university, so I was quite young, I discovered that C# is basically the attempt of Microsoft to do its own Java
again.
Yeah, again. And that fact was quite entertaining for me back then, and still when I no offense to any Microsoft guys, but when I heard about C# I was like, yeah, it's just another Java. Come on, guys.
Actually grown in its own direction and found in its own niche,
sure.
its own area. Yep.
For sure.
So, by the way, one more comment in the We're Community Platform chat is the recording of this Star 7 demo. So, guys, in case if you're interested in how exactly all of that started, please feel free to watch it after our event. So, let's possibly jump down to the next fact.
So the next fact has codename org. Java originated in June 1991 as a project called org, developed by a small team of the engineers at Sun Microsystems, as you know. They called themselves as the Green Team. James Gosling, Mike Sheridan, and Patrick Norton was inside this team, were inside this team. And the name org was chosen because the org tree symbolized strength and endurance. Time proved that the name was very fitting, even pathetic. Though in 1995 it was changed to Java, since org was already a registered trademark.
Actually, yep. Again, about the different possible direction of development of the language, at least its name. But basically, the interesting fact I've heard, and I still can't find the actual proof for this, that possibly the Green Team name also was not just because of eco-friendly way and all of that jazz, but just because James Gosling preferred to use the green color scheme for the slides where he presented his original product, his first ideas around this org stuff. And actually, yep, I would like to point out that basically both the names are absolutely correct and fit in language very well, taking into account huge history of Java. Oak name also would work well for it. But as for the Java, being passionate about coffee, I'm 100% agree that this is something which has become the vital part of the development process and of the vital fuel for the developers. So, yep, I see that there are a lot of points in the chat.
The main point is that people think that Ryan Gosling creating Java. Yes, he was near.
Yep, definitely.
I thought he was quite young to do that. The other thing, I just thinking that name Java, even I like it, but there is the problem with letter J. And this problem is that if you know some history of Latin, the letter J wasn't there from the beginning. There was no J, basically. There was just I with dot, yeah? And then the J, the symbol, how it's written, it was just introduced in the book. So basically, I was written with this like tail in the bottom. And then there was a separation, this letter into two literas. So I and J. And the problem is that in different languages, in different languages like Romanian languages and their children's, let's say this way, or again, brothers sisters, this letter J has different sounds in it, because basically there was no sound behind that in the beginning. So in some languages is like J, in some languages is like Y, in some languages like Spanish is H, etc. And that brings a lot of complications here, because Java, having this J in the very beginning, has their own name. So in Spain is could be Java for sure. In some other countries could be Java, and other countries Java. So it's a problem. So I just think that maybe with org it was really easier for
a bit
everyone.
simpler.
yeah. And there was no like arguments of how to call this language. So yeah, I hope we agree here that is Java.
So in turn, we have a lot of great variations, and we can choose the one we love the most, which is also great. Yep. And by the way, I see again one more fact in the chat regarding the naming. This is the reminder that C# is also an interesting name for the language, because it's about C with 4 pluses in comparison with C++. So more pluses for the sake of pluses. Okay, yep. Thank you very much, guys, for actually joining us in this conversation. I also like some comments like J++ finally Java with classes. So yep, a lot of interesting facts from your side, which is great. And let us jump to the next fact from our side.
Next fact, the magic number CaffeeBabe. I think you should to know that Java class file begins with the magic number, and this is CaffeeBabe. It was invented by James Gosling. And if you don't realize before, it's one of the creators of Java. When he and his colleagues were having a lunch at the place called St. Michael Alley in California, the team jokingly called the place Coffee Dad, and noted that it was a valid hexadecimal number, since that number was already used by another language. For its file formats, James started to looking for another 4-character words that would fit after coffee. He came across the word babe, and they decided to use it. It's simple.
Yep. Actually, it's really like how cute it sounds. Definitely, CaffeeBabe. And by the way, this is something like similar to the phenomenon which you guys might have already heard about. The phenomenon which is named the Tetris effect. When you play a lot in this fantastic game, sometimes you can feel a strange thing in real life, when you can see how different things around you also can be placed together in order to build these beautiful lines which can be erased. And actually, I think that this is something similar when you work with the code days and nights in a row, and you do quite a lot of stuff on a daily basis. You start seeing the code anywhere you can find it, even the hexadecimal numbers in the actual real life. So this is about how we invent some interesting things from just daily routines, allowing our brain to refocus on some other stuff and given the chance to bring the brilliant idea alive. So, Roma, any thoughts from your side on that fact?
Yeah, maybe just like, I'm here to just give some jokes after some dead jokes after after your slides. If the name was Oak, we will not have enough hexadecimal numbers to fill it in the class name. So yeah, good that we have Java, right?
Yep. So we have some more facts and not too much time. So Anastasia, let's proceed.
Okay. So, and I think the last one from our sites. WebRunner or Hot Java. Sun Macrosystem actually developed its own web browser in 1994. Initially, it called WebRunner, and later it became Hot Java to showcase Java's capability, particularly applets. It was one of the very first browsers to support Java, demonstrating the language's web potential.
Yep. Again, this is a teeny tiny spoiler for my presentation. At least one particular word you will find it later. But anyway, this is again about the development of the infrastructure around the language. So this is interesting that definitely the language doesn't exist in a vacuum. So we try to build some products around it. We try to build some toolset around it, and during this like web development era, which was like the very beginning of the language itself in the timeline as well. So we do have this process of like building some products similar, useful for the internet. And definitely Hot Java was the product of its time. But after that, it was also removed for the sake of focusing on the most important things, products for the language progressing itself. I think this is something similar to what's happened with the Solaris OS, which was also the operational system built around Java. And basically, this is about experimenting with some larger products with some interesting new directions where the language could grow. But it's important to understand that still the basis of it is the language, which continues to grow even despite the fact of decommissioning of some products based on it. So, Roman, any jokes from your side?
Just a simple fact, soft without any additional comments.
Yeah, I have not a joke, but like, engagement to the audience. Guys, can you put plus to the chat? No, not a plus. Let's make it more fun. Write applet in the chat if you write something for Java applets. I would be first, like applet.
Actually, yeah, the same thing for me, but unfortunately, I'm a bit busy with the boards right now. But anyway, yep, I totally agree that this is the interesting product, and I will touch it briefly in my presentation, which actually is coming soon. So I think that we can finish for now with interesting facts from the history of Java. And in order to wrap up, let me remind you guys that today we have our fantastic quiz, which goes in the background. And in case if you know something about the retro technofact stuff and you would like to compete with colleagues and to check your knowledge in this direction, please do not hesitate to follow the link on the landing page, as well as I think the link in the chat will be reshared one more time after this part of intro. So please feel free to join, and we will be happy to see and hear the feedback from you.
Yeah, and very important thing, guys. If you go to this challenge and register, please use your real email, because this would be the email where we would send prizes and contact you. So please use your real emails where we can reach you.
Yep.
Yeah, we will try anyway with email we will have in the system. So if you put some strange things there, well, it's up to you. Okay, so I want to say thanks to Tanya and Nastya for these great facts. So guys, I hope you enjoyed that. And we have, by the way, a lot of word applet in the chat. I haven't seen this word for like 15 years. So yeah, that's great. So huge round of applauses for you. Thank you very much. I think all our audience joined me here. So thank you very much. And yeah, have a great conference. See you soon. and we are continuing with Java 1. I like with our intro video, this VHS sound. I haven't heard it for quite a while, and it's something from childhood. This like the sound of VHS cassette being brought into the tape. So yeah, that's nice. Join me in the chat, guys. I love this interaction with us. I love that you writing your messages. In online words, it's really important to see the audience, to see this interaction. So thank you very much. Thank you very much for being active in the chat. So we are right on time, which I'm really glad of. And please let me welcome the stage the speaker. You haven't seen her yet, for sure. So Tanya, welcome back to Java 1.
Thank you. Thank you very much.
And guys, this is another thing which I want to share with you. It's like it's 5 years of this conference, so finally I can share some facts from back. So as I mentioned already, we have a quite a huge org team. You saw their faces, and it's really hard to me each year to ask them to join me here on the stage. They are really incredible people. They are genius. They are genius in preparing conference. They are very talented, but they are all shy. And that's a problem. I try to bring them here, and finally we have a talk from Tanya. The more amazing would be if I will prepare a talk on Java 1.
Yep. Looking forward to seeing it at least on the 10th anniversary.
we need to make someone host in this case. So someone should host. So Tanya, please think of that. So next year you would host Java 1 conference, and I will make it
the roles.
Yeah, let's make it happen. So coming back to I love this atmosphere on this conference this year. It's really fun. So Tanya, speaking about your talk, what would it be about?
Actually, today I will continue my role of Java historian and possibly even Java archaeologist. So first, I would like, before the presentation, since we have this great small talk, great opportunity for me to actually give some credits to the guys from our organizational team, and in general, for the ones who have inspired me to this talk, I would like to say special thanks to the Genius podcast, the Genius talk, in case if someone knows that specific content from EPAMers for EPAMers, because especially for Maxim Daderkin as one of the guys who have shared this inspiring story about the JAP, which was kind of long going in the language with a lot of its like controversial movement around applying, candidating, and all of that stuff. So actually, that's kind of interesting. So it became interesting for me to understand what exactly can be brought to the language by removal of something from it. And my presentation will be about the facts about the particular technologies which has been removed from the language, but not in the area of how we could replace them and whether they are actively used, but which lessons we can learn from this in terms of why this happened and how we should actually maintain the key principles of the language when we do something similar with our legacy code.
Yeah, well, sounds great. Sounds great. So let's jump into your talk. Before that, let me remind our audience that we have two chats. One on the We Are community platform, another one on the YouTube. I will monitor both of them to announce your questions to Tanya in the end of the talk. So please use this opportunity to share your questions and ask them. And also feel free to share your emotions, your thoughts during the talk. That's also very interesting. And today, in this talk, we will speak about a lot of historical things. So I think, guys, that's really a place for you to share. All the conferences place for you to share your emotions. So use this opportunity.
And cool stories.
And cool stories for sure. So let's dive into the topic. Tanya, good luck, and let's go.
Thank you. Thank you very much. So, let me remind you guys that my talk's name is Java's Forgotten Future, and I have the additional name for it on the slide, The Paradox of Progress Through Subtraction. This is exactly what I've already mentioned during the small talk with Roman. So basically today we will consider how exactly the language can move forward by removing everything which is not necessary actually in the language. And I don't don't like actually this slide in terms of I do not like to tell a lot about myself. So as Roman has mentioned, we are too shy. We are just humble operatives. Who am I? I am Tatiana Bravkova. I am software engineer and team leader at EPAM, Java and cloud enthusiast. I really love computer games and some funny stuff in sci-fi, sci-fi movies. Today I will play a role of the real time and space machine for you in explaining some interesting facts and outcomes from them in terms of the Java language history. So let's begin as the real programmers from the chapter 0, from the problem statement. So in general, that's an interesting fact that the Java language, with its principle write once, run anywhere, actually uses this principle not just across different platforms, but also across time. And actually, the language develops smoothly in terms of the backwards compatibility, and we can even run the code, at least partially, the code which was created for the Java 1.2, for example, on JVM for the JDK 25, and it might even work properly. So basically, this good movement and attempt to maintain the language as stable as possible leads us to another problem. So how not to get too much technical depth around that? And in order to avoid all of that, basically Java has decided to go in a smoother direction in terms of multi-year transparent process of deliberate removal of features from the language and evolution in general. So it's worth to mention that despite some other languages which have done a lot of breaking changes through their history and broke the compatibility, requiring to apply some revolutionary changes, Java decides to go in a bit different direction and allow us to actually maintain our applications workable as long as it's possible, still removing some features from the language. But why exactly we do this? So any subtraction from the language is the actual design signal. And these signals sent us by removal of features which exist, or, which is also important, rejection of some enhancements which are suggested by the community, are basically important things which language says to us. So this can be security posture. For example, features removed from the language might actually lead us to some security flaws. So it's important to avoid this. Again, this is about the performance philosophy. So rejections of some proposals or some removal of some features basically might be caused by potential compromise in the runtime efficiency. Also, it's important to note that there are some excessive maintenance burden, which basically should be avoided in order to allow the language to evolve and to evolve faster. As you can see, the language has started to evolve faster recently, and it's important to avoid all excessive stuff in case if maintainability of it actually doesn't bring too much benefit. Again, developer productivity is one of the important values. So basically, the balance between complexity and benefits of some features actually leads us to leaving the most important and the most useful ones in case if we have different options on that. As you understand, definitely there are a lot of ways how we can write the similar code in the most of cases, and some tools just are not so effective in comparison with their complexity. And finally, ecosystem boundaries. So sometimes we need to understand that this particular feature is not necessary, even not for the 99% of the users of the language, but even in case if it's not in use for the majority of the developers, possibly this might become the third party solution, and this should be actually removed from the language for the sake of development as a separate product. This is also important, and this is also the way how some features have grown. So after discussing this, let's say, background, these signals, let's see some particular examples of how exactly this happened, why exactly this happened, and which alternatives have been introduced in the language. So the chapter 1, what we actually removed from the platform. So what has been removed from the Java features. Let's begin from something very simple and possibly well known. And actually, the fun fact is that this feature is not yet removed. So basically, the object finalize method. As you can understand from this notation, and as you might probably know, this is the alternative option how to clean up the resources with the non-memory related resources after their usage when we should remove the object from the memory. So basically, this functionality has the good intention to allow us to close everything, to correctly, properly handle everything before stopping the system, before removing some project from memory. So this is the vital part of the memory management. But still, this particular feature is no longer in use because actually, the rationale for the removal of this feature were first performance issues. So I would even switch the order and first focus on the unpredictable behavior, because this is important to understand that we do not guarantee when exactly the finalize will be executed. And returning back to the step number 1, performance issues, we also can't guarantee for how long this particular method will be executed, how much memory it will require, how much GC life cycles it will actually go through. And this definitely brings additional pressure to the system, sometimes not predictable pressure. And also, definitely some design flaws and even security flaws have become the reasoning for removal of that, because we still can have the partially instantiated objects, partially removed objects. We can also bring some additional complex insecure logic, which might be a part of the finalized method execution, which potentially might lead us to a lot of unpredictable issues while trying just while aiming just simply to clean up all the unused resources. So as you can see, the decommissioning timeline, this is again about the long-going story, and not the longest one which we will see today, but Java 9 has become the first version where the initial deprecation of the feature has been announced. Then in Java 18, we deprecate, so the feature has been deprecated for removal. So this means that this, based on the JAP 421, this particular feature will be definitely removed from the language. And we're still waiting when exactly it will be removed. Timeline not yet finalized, because so another side of any removal is that this might be a part of some legacy code which still might be in use, and the language should guarantee as smooth transition to the newer versions as possible. So removal of this mechanism is not so straightforward task. But in case if we would like to consider alternatives, definitely the simplest one and the easiest one for now is just to use the try with resources. One of the best features in terms of the managing of this stuff related to closing some resources, when we just can define the resource which is auto-closable and guarantee that it will be handled properly, it will be automatically closed. We do not need to think about that, almost definitely. So there are some cases. But anyway, this is like the simplest solution which we can find to manage the resources in case we would like to avoid any stale, obsolete technologies. And an interesting alternative I find for myself, actually, I haven't applied this feature. Guys, would like to hear from you from the chat whether you have had experience, the real production experience with this. So have you used the Cleaner API? Because basically, this is even more powerful toolset, again, built around the ability to register and remember resources, which should be then proceeded with the cleanup of them. So basically, what we can do, we can define this cleaner, which we would like to then use as the register. Basically, I saw some recommendations to define it like even not the on the per class basis, but sometimes per library basis. And basically, the objects which we need to proceed removal with are become available for the cleaner when they are have the phantom references only. And in case if we need to clean up the memory, we actually execute some code which basically is also just a regular runnable, where we can define some state and the resource which we would like to release. So actually, yeah, again, this functionality is a bit more complex, but a bit more powerful. Still, there are some issues which are similar to what we might meet with the finalize, but this definitely safer and this definitely much more manageable in terms of how exactly and when exactly we could expect the resources to be released. So we will talk about the major outcomes from the removal of the products later. Let's jump to the next set of methods. Basically, the thread control methods are also well known across the Java language since quite a while. And the interesting fact is that some of these methods have been removed, or at least it's better to say deprecated, for quite a while. So, as you can see in the decommissioning timeline, some of the methods have been deprecated since Java 1.2 in 1998. And they have gone through the long path before being finally removed somehow from the language, at least some of them. And actually, I would like to point out the rationale for removal, especially for some of these methods, like the destroy method. Basically, in case if we take a look at the definition of this method, it has never had it has never implemented. So basically, it throws an error instead of just being implemented. It's possible to override it, but definitely this didn't make sense originally. So that's why it has been deprecated also almost at the very beginning of the language history, and then has been finally removed in Java 11. So at least some of these methods have been removed. Again, in case if we're talking about the thread control methods, it's also important to add some points on other rationale for removal, like safety issues and deadlock risks. In case if we take a look at the example, this is the clear view of how exactly this might be dangerous. So we can have the corrupted state of our objects, of in general, of the state of our particular runtime. So it's important that we should also manage and thoroughly orchestrate the ordering of methods, which we call like suspend and resume, and guarantee that the ordering is always correct and all of that, which is also important and should be taken into account while operating such, let's say, low-level functionality. So that's why all of that methods earlier or later have been marked as deprecated. Some of them have already been removed. For some of them, we are still waiting for that. And in case if we are talking about the alternatives, definitely instead of just stopping, we can try to interrupt the thread and instead to try to handle the interrupted exceptions and do this properly in order to stop work as safe as possible, giving the JVM the chance to stop everything and to do this properly in the proper way, proper direction. And in case if it's possible for us and if there are no specific concerns, definitely it's better not to use the low-level constructions and consider usage of some modern ways with the executors, with other synchronization toolset, as well as the thread toolset, which has been has grown in the language for a while and which actually is rich in terms of any options of management of how the threads should be interconnected with each other, how they should react, how they should work in parallel, and actually have access to the resources. So a lot of stuff is already a part of the language, and it's not necessary to dig into the lower levels to manage this properly. So you can consider the Java util concurrent library abilities for that. Definitely, this is all of that are well-known facts. So let's jump further to possibly less well-known toolset. So it's worth to mention that later we will talk about the toolset which we've already mentioned during our intro, so the applets, and actually. In addition to the benefits, they have brought a lot of insecure code which could be executed on the machines of users, together with some additional technologies which also had such abilities, Java Web Start, as far as I remember. So basically, in order to avoid the direct access to some resources which might be unsafe, like, for example, we could have access to some, etc passwd functionality to manage the permissions of the users in the operational system. This particular security manager library introduced in Java aimed to allow to set up the permissions within the language, within the library, to expose only some particular functionality for particular permissions, and to allow to have the access to file system, access to particular files, to execution of particular methods and classes and all of that stuff, creating kind of a sandbox which might become the safer environment to run in some insecure code. But unfortunately, or fortunately, can't say for sure, the history actually will gives us a chance to understand it better later, possibly, or we can at least say right now that basically this functionality has been removed. The rationale for removal is that this security manager was not so actively adopted. Definitely, the complexity of maintaining all of that permission stuff as a part of internals of your libraries would bring high maintenance cost, and there are a lot of better architectural approaches and framework options which could provide us with ability to do this. And there are a lot of modern options of how we could manage the security and the levels of access to different functionality. So in case if we're talking about the decommissioning timeline, basically, This feature was permanently disabled in one of the latest versions of Java. And again, we are talking about the long way forward, at least several years. So we have the deprecation for removal, then warning phase, where we see the warning while using some features and when the feature is enabled in runtime. And only after that, some permanently disabled scenario, and the future releases actually imply the API removal. So we're still waiting for them again. And this is important to understand that all these warnings we can see during the runtime phase are actually important, and we should pay special attention to them to understand which exact functionality libraries of our libraries use, and we possibly might need to avoid in future. As for the modern alternatives, definitely in case of managing the, if we're talking about management of access to some particular packages and execution of some methods, modular system introduced for that purpose would work perfectly. There are some also not so, like, let's say, recommended, but still potentially feasible options in terms of the API interception with bytecode manipulation. Still, this might be an option in case if you really need, and you have strong opinion that you need some management of the lower level resources and components. And definitely, the sandboxing around the code you execute can now be built in a lot of layers around the JVM, around the execution of the code. So basically, we can do this by means of having our containerization. So virtual machines, we can have some particular setups of execution for some compute resources within some clouds, where we can also guarantee some kind of security and different level of access. And we also have kind of prepared sandboxes in case if we're talking about serverless cloud computing. So we have a lot of layers of this sandboxing we can build around our code rather than integrating it deeper into the language itself. So that's why I would say that this feature basically can be easily replaced on a different set of levels based on your particular goals. This one is actually kind of interesting in its own way, because this is about the protocols of interconnection and communication between different services. And the RMI protocol itself and the RMI as part of the language is still alive. It's important to understand that we are not talking about the overall unavailability of this remote way of communication between the services. But there was a very, very specific way and very specific scenario, which is named RMI activation, where we could remotely activate some kind of procedure on this server without like having it, let's say, waiting for us, but having kind of a proxy which could tag it, etc., etc. Kind of complicated stuff. And basically, this completely explains the rationale for removal. This feature was introduced but haven't got too much community support. So the traditional RMI communication with the just description of the interface of server and client and methods stubs between them were much simpler and better to be easier to be understood. And again, obsolescence. So we do not need this feature anymore, taking into account a huge variety of different protocols for communication, different approaches, architectural solutions, which could help us to communicate between the services. So like gRPC, REST, like the modern ways of communications, which will be touched during other talks today. So the MCP protocol for the communication between AI agent and third parties. So again, we have quite a lot of specific ways of communication which might be clearer to understand, which could have their own goal, which could be clearly defined with the clear protocol of how exactly they are connected, with the more secure approaches of how they are connected. So that's why this particular functionality, the activation part of the RMI library, has been actually removed in Java 17. And as you can see, yeah, definitely, I will not touch too much this like the modern alternative in the REST API with Spring Boot or something like gRPC or something. Again, we still have even the standard RMI in case if we need to communicate between the so services, and we can organize the communication in terms of calling the remote procedure on server from our client. This part of the library is still alive and it still works on the newer versions of Java. Can say for sure for how long, because again, this is about some potential security flaws. This is again about the complex maintainability of this, let's say, quite old protocols of communication. But still, this is the part which is at least clear in terms of how to use it, why to use it, and why exactly it's implemented that way. And it's easy to understand in comparison with this like more complex RMI activation approach. Now, sure. So this is the JavaScript engine, and this is the combination of different languages. As you may probably remember, this is the way how we could try to execute some JavaScript code within our, let's say, so on the engine, which is a part of our Java code. Basically, definitely, it was the great first step, or one of the first steps, let's say, because this definitely was not the first one, in that direction of combination between the different languages and execution of them. But yep, some maintenance challenges and better alternatives like GraalVM with, for example, support of something similar, basically have replaced this engine. So that's why it's already been removed. But again, we are talking about the long history of removal. Even such, let's say, niche feature in some direction might be explained. So might have the long history, which can be explained by attempt to support some maintainability for as long as possible. So basically, we have the removal of this feature only in 2020, but it was originally deprecated for removal 2 years before. And actually, it was in general alive for just 6 years, which also tells us interesting story about not all the new features, or almost new, or so kind of fresh features are in active use, which are not in active use. So it's better to say, basically will continue stay with the language for a long time. This is also the important. So the dynamic of how a language removes the features grows, and it's basically might be expected that some newer features might be removed faster in case if they have better alternatives, or in case if they are not in active use by the community, they do not have active support from the community. Still, this is the separate project which can be used as standalone dependency. And we definitely have the better alternative in terms of GraalVM, which also can do something similar and much, much, much more, which is important. And again, we have alternatives in terms of external JavaScript engines, which we could consider as an option to be run as a part of our setup. So basically, quite a lot of alternatives, a separate product which is still available in case if we would like to experiment around it. This is the current state of how we could replace the Nashorn. This is about the quite an old and even rarer stuff. This particular compression toolset, as well as compression protocol, PAC 200, is actually a part of how exactly these our products can be packed. But its complexity and the better alternatives in terms of the compression protocols have actually led to the deprecation for removal and then to removal of this feature from the language. The important fact here is that this is not just about some kind of particular piece of code we write, but this is about how our tools are packed. We have the modern, better alternatives. Here is the overall example. Here are the important part of it. gzip as the packing protocol works completely right, and we have the ability to create optimized runtime images using JLink. So definitely this support of such kind of old tool set, which is too specific from the language for the language, might even break some kind of initial architecture design ideas of the language, like write once, run anywhere. So this is important to try to get rid of such features in case if they are not in active global use. Corba is the communicational protocol again, and some Java EE modules. This is the interesting example of how some features have been deprecated, removed, but not like removed in terms of full cleanup from anywhere, let's say. So we still have the alternatives. We still have the third-party products and projects supporting similar functionality. So we have the Jakarta project, which supports these features, which actually were a part of Java EE. And this cleanup of the language from the features which have been like combined together in some point of time, but haven't been necessary for the core functionality of the language. It's also important stuff to be considered to be like split from the language, to be removed from the language, but distinguished from it, and still staying available as separate projects in case if there is still the niche where they are necessary. And Applet API, finally we reached it out. The earlier times of web development actually were full of different applets, and as you may probably remember, so Adobe Flash stuff. So basically, together with these amazing features, which might be animated, interactive, and might bring a lot of benefits in terms of executing some code on the client, actually, they also brought a lot of security concerns. They were complicated in terms of support, so the browser vendors have decided to avoid all of that stuff. Definitely, it have become obsolete because we have quite a lot of modern technologies which might work better, safer, and even the development of the key web component. Not the components, this is not the right term, but key web technologies, let's say. So the HTML, CSS, JavaScript as a language. Basically, development of them have brought all of that stuff to being absolutely unnecessary and even dangerous in comparison with the better modern solutions. So that's why, unfortunately or fortunately, we're waiting for the applet API to be removed in the next version of Java. And actually, we do have the better alternatives, definitely. So we still can maintain, for example, some backend stuff computation by means of the traditional communication protocols and approaches like REST API. We can use JavaFX for some particular components. We can just combine our knowledge of Java while writing the backend and writing the front end on the better suitable technologies from different stack. So this is the route which removed the complicated, insecure part of the language, which was the product of its time, definitely, and was necessary at the moment. But currently, it's already obsolete. And a brief overview of some removed tools and components. So basically, Jhat. You have probably seen some notes on that tool. So basically, this is the heap analysis tool for viewing heap dumps. And this tool was removed because of the better, superior alternatives. All of that stuff with the so the feature was experimented. It was not actively supported. It has become out of date, and definitely, in case if you use, for example, Eclipse MAT for the heap dump analysis at least once, you can understand how well it works and how well it covers this area. So you might not need the other tool set in case if you would like not just get the particular dump information, but to have this comprehensive report with some ideas on where exactly you might have the bottlenecks and what exactly your heap dump consists of. Again, Java H tool, which is native header generation tool. It was simply replaced by the Java C with the particular key. So it was just removed as a standalone tool, but has become a part of another tool for the sake of simplicity and clearer state of the language. And it's no longer needed as a separate tool, actually. And as I've already mentioned today, so Solaris and Sparse, so the parts of the architecture and platform for the operational system around Java have also become obsolete because Oracle no longer developing this tool set. High maintenance cost of it can be one of the explanations and rationale for removal. And definitely this burden and obsolete functionality maintenance cost would block new feature development like Valhalla, Loom, Panama, etc. So that's why it's been decided just to remove these features for the sake of saving time and resources for the more effective and useful ones. And finally, chapter 2. Still, despite the fact that some features are introduced based on the JEPs, and a lot of the most of features are introduced as JEPs, as suggestions to improve the language, some of them are definitely withdrawn, rejected, and sometimes they still stay in the candidate state for a long time and become a part of the of another features. It's important to understand why exactly this happens as well, and why this withdrawal and removal on the earlier stages is also important. So let's consider several examples. Enhanced enums. So basically, this is the suggestion to consider having these enums as functionality supporting so some specific syntax like generification, or ability to for methods to be introduced only for some individual specific constants. This is basically huge, interesting, powerful toolset which could become a part of the language, but it also has brought a lot of complexity, a lot of generic interaction problems of how this should be interpreted in the language, of how this should be maintained in terms of compatibility with other language features. There were some well-formedness issues. and definitely a lot of complexity without solution. So the decommissioning timeline is interesting here. So after the proposal of JAP, we can see that there was a phase of initial resistance where the features introduced like described in this JAP were improved and clarified, and there were a lot of communication on how this still might become a part of the language. But later, after prototyping revealed, so it actually revealed not just the benefits, but also some fundamental problems. And finally, 3 years later, this JAP has been formally withdrawn. So we haven't got quite a lot of interesting features which might become the forgotten future of the language and alternative way of the development of the enums as structures. But also we haven't got a lot of complexity and problems which might be brought together with this feature. Next one is string templates. This is kind of clear feature in terms of understanding of reasoning. So basically, we could have some kind of basic syntax with the word like str or something. After this, we could describe the template with some placeholders, and then these placeholders could be used. So basically, we have the similar syntax in Python with f strings, with Scala with s strings. So we have quite a lot of options of how we could do this in different languages. And there was a suggestion to use some kind of alternative in Java and to introduce it, for example, to have some kind of template processors which could help us with some specific cases, like building some SQL queries, for example, say from SQL injection. Also, like for the JSON object structures, etc. But there were quite a lot of debates around how exactly this should look like. Again, the design complexity and some fundamental reevaluation of this feature led to the following timeline, which is interesting. We had this feature as the first preview in Java 21. Again, we had this as the second preview in Java 22. So basically, this functionality was a part of the language in previous stage, but still. And we have this like preview, third preview proposed for Java 23. And finally, before the Java 23 finalization, so before the actual release of the language, unfortunately or fortunately, again, this proposal was finally withdrawn. One more proposal, which might actually feel similar to what we have got finally in the language, and this is absolutely true. So the raw string literals were the backtick syntax was applied in order to have this like specific string which might be multi-lined, which might not require some like pluses with all of that movement between strings or something. So it might look a bit simpler than what we have got in the language earlier. But there are a lot of different issues in terms of the like overall design concerns with this approach. Basically, the better alternative was finally found and introduced in the language. So the actual text blocks, which as you can see, look a bit like simpler and clearer, but still might need to be escaped in some certain context. And this raw string literals JAP was finally superseded by the text blocks. And finally, the long story, which is still in progress again. So the feature, or it's better to say a set of features, which stays in kind of limbo, which is currently in the candidate state for a long time already. Basically, these are a lot of different proposed improvements in terms of how lambdas are defined in Java. For example, one of the options was having the underscore for unused parameters. So there also an option to allow lambda parameters to shadow enclosing scope variables. Like, for example, in case if you define the key variable with some value before your lambda, and for example, within the lambda, you define the expression where you use this keyword key again. So definitely this is not allowed in the actual language, but you could. So there was an idea to consider option of how this could be allowed and lead to more flexible variable naming. So basically, this is interesting that this particular JAP has become the groundwork for different other improvements already introduced and incorporated into other releases. So the remained features are still under consideration. They might become a part of the language. They might not become a part of it. We will see. So finally, the lessons learned from my long story today. The key takeaways. Basically, removal of features like finalization, thread control methods, security management actually demonstrates commitment of the language to eliminating unsafe patterns, even at the cost of backward compatibility, which, as we have told a lot before, is one of the key values of the language. Again, features like AirMy activation packed to 100 Nashorn Corba were removed primarily due to high cost of maintenance relative to actual usage. So, in order to focus on modern features, the language decides to avoid and get rid of the obsolete ones. Again, the platform modernization, the global platform modernization, not only related to Java, actually can be seen through the removal of applets, some legacy tools, platform-specific ports. So basically, this shows this Java evolution from its roots to a modern, streamlined platform. And actually, yeah, definitely, the communication and the actual ability to impact on how exactly the language grows is shown through the preview process and how some features have been withdrawn. Preview process works and matters. So that's why the community feedback is necessary and important. Actually, I sometimes I'm really sad why exactly the Java community, in terms of the overall users of Java, our overall Java developers community, might not be so active. Like, for example, the community of some web toolset, where they communicate a lot directly on some features on like with the browser vendors, with the authors of the languages, to make them better. And I think this is something which possibly Java engineers might miss sometime. And it's important to take part in this conversation and to give your feedback. And backward compatibility balance. So as you can see, the most of the processes I explained and showed today were long going. So 5, 10 years, even more of careful. So this shows careful balance between the progress and stability, giving us as developers ample time to migrate. And we shouldn't waste it, taking into account our overall tension to actually intention to stay with some version of Java as long as possible, because we need to develop new features rather than spend some time on migration. In terms of migration, some possible tips, tricks, migration strategies which you could consider just as an ideas. So if we're talking about some potentially removed features, in order to migrate safely, we could monitor some deprecation warning. We could use some tools like GDepper scan, which is a part of the JDK, to identify some deprecated API usages. We could test some features, trying to disable them and see how exactly our application, our runtime will behave. plan some migrations during major version upgrades, and leverage automated refactoring tools where available, taking into account the development of AI technologies. This is the wide range of options here, how exactly this should be automated and simplified, and how exactly we could transform our code to the newer version at the lower cost. And as for rejected features, in case if you see some interesting job and you would like to experiment around that, don't depend on preview features in production. Definitely, by any means, do not do this. In case if you experiment on some features, with some features, please provide feedback during these preview periods using the appropriate channels, because this is important to actually see the response from the community in order to move either forward or backward with such kind of jobs. Again, be prepared for the feature changes or withdrawals in case if you try to adopt some new features which haven't been globally fully officially included into the language. And follow JEP status changes on OpenJDK website in case if you're interested in where exactly the language actually moves forward. And finally, some ideas on best practices for long-term Java development. Definitely stay current. At least try to regularly update to the supported Java versions. It's great that currently the modern environment stimulates us to move forward. Like, for example, some end of support of the language features or some kind of cloud infrastructure which we might utilize for running our environment and which requires us to move forward with the versions, actually push us in the right direction, in the direction of the staying current. Again, monitor deprecations, pay attention to annotations, warnings, and related stuff. Test early. So use early access builds to identify some potential issues which might be caused by deprecation of some features and potential removal of them. Avoid internal APIs and experimental features. Sometimes you might feel the strong desire to use this particular internal function which fully suits your the current use case, but this might lead to the fact that it might be changed unexpectedly and in the unexpected moment in the newer versions of Java. So you need to take this into account while deciding on which exact APIs to use. In case if you have this great opportunity, participate in JEP discussions for preview features and give your feedback on any concerns or any benefits you see in some features. Definitely you need to have a plan for change. You need to think about awareness, how exactly these particular features will continue to work in case if other features are removed, and if you use something which seems to become obsolete and there are some plans for deprecation or some discussions around deprecation of that. And the most controversial point, but in case if you do this, good for you. I am absolutely happy that such people exist. If this is the case, track which JDK features, like major features, possibly obsolete, deprecated features, which might be removed, your code relies on, or at least take this into account while working on the future improvements and future development of your product. And basically, it's worth to mention that a lot of principles around them that works not only for the language we use, but also to the tool we implement and we create, and to the legacy code we actually develop, because any code which has already been developed can be considered as legacy. So we should also pay attention to try to do deprecation process of our features as smooth as possible and to basically be able to support these key values which language actually studies us to follow. So more or less that's it from my side, and I would be happy to hear the questions from you guys, but I see that I don't have too much time for that.
Yeah, first of all, thank you very much. Very great talk and great overview on all features. And it's a pleasure for me to read in the comments that people see the features they were working with. Like one comment from Yuri, like feeling so nostalgic about those features. For some reasons, I've been working with them since 2012. It's like quite a while, quite a while.
That's
So
cool.
yeah, maybe just a comment from my side. It's like, guys, like just a bit of experience. uh, I recently migrated several projects from one Java version to another, and it's really easy to do so. It's like it's really easy. You basically just switch version. Not a lot of things you need to change. More problems when you need to migrate framework. So migration of Spring, like from 2.7 to 3.1, this is like hard. Migration of Java, it's really easy. So don't wait. So it's really nice. Java 25 was released like 2 months ago. So yeah, Java 21, it's definitely your choice now. You can even
Yep,
do
yep, yep.
20,
Not
25 if you
Java
want.
25, at least for now, at least for several months.
Yeah,
So more because
not
yep. Anyway, we need to wait this version to stabilize a bit.
well, not about a version, but more about frameworks. So not all
Yep,
frameworks can
yep, yep,
support
yep, yep,
that.
yep.
Your
Definitely.
project can use some library which not support that. So yeah, we don't have a lot of time. We have one question. I will reformulate it a bit as there already an answer from Maxim. So what do you think about unsafe, which was marked as deprecated in Java? And so what is your opinion about this library? Because it's marked to deprecation for quite a while ago, I think like around 5 years, maybe more, but it's still somewhere there. So what do you think about that?
Actually, I think that this is again about the key principles I've explained and shared with you guys today. So, definitely the functionality was marked, which was marked as deprecated, in case if it has become a vital part of the language and the libraries we use and the legacy code we implemented. It's not so easy to fully remove it. So that's why possibly it stays with us for a long time, despite of the obstacles, despite of the issues it might bring, because the stability of the language is also important part of the overall framework. So that's why I do believe that if feature is marked as deprecated, it should be finally removed from the language because it has already become obsolete and we should avoid it. But anyway, this might require some time finally to get rid of it, and this is okay, but we should keep in mind that in case a feature is marked as deprecated, it doesn't seem to be a good idea to actually introduce it in new functionality. And in turn, it might be a good idea to try to find the better alternatives in terms of overall architecture of the products we develop.
Yeah, great. So, Tanya, thank you very much. Great talk. And thank you very much for being part of Java On and being part of Java On org team. Thank you very much.
Thank you. Thank you to be here. So thank you guys and have a lot of fun with further talks.
Thank you. And we proceeding with our conference. Thank you for being with us, guys. I will not take a lot of time as our next speaker is already waiting on the backstage. So I want to remind you that you have ability to rate our talks. You can do it on our community page. There are ratings. Please put 5 stars. Yeah, you put your stars for our speakers, and that will be great. And also we have some activations for you. So please find them on our community page. We have Kahoot challenge. Don't forget to put your real email so we can contact you and bring you some prizes. And in this case, it's IntelliJ licenses, which we have kindly presented for us by our sponsor, JetBrains. Thank them a lot. And here I can invite our next speaker to the stage. It's Anton Rakipov, developer advocate at JetBrains. Anton, hi, and welcome to Java Conference.
Hello, hello. Great to be here.
Wonderful to have you here. So today we celebrate Java 30 years, like through all this year. So in which year, in which version of Java you joined this community? Can you remember?
1.3, some kind of update of 1.3.
Wow.
I don't remember exactly.
Wow. Yeah. I joined when it was 1.6.
It was a nice
And
release. It didn't have any features. It added a few performance updates, and I think Java scripting API was also included.
yeah. And like today, we through all topics we remember about applets. They were still there in
Yes.
1.6. Okay, so yeah, let's not waste time, and we will jump to your topic, so you can share your screen meanwhile. Guys, I would like to remind you that we have two chats, one on YouTube, one on Vera community platform, depending on where you're watching us. I will monitor both of them and I will ask you questions, and Anton will answer them in the end of his talk. So please use this opportunity to put your questions in the chats. And yeah, I think with this we can start. Anton, good luck, and let's
Thank
go.
you. Thank you. Thanks for the intro. So my talk today is about debugging, and specifically about debugging Spring applications and what we are cooking inside so-called Spring Debugger plugin for IntelliJ IDEA. It's a work in progress, and but we already have this plugin on the marketplace that you can download and test it, and even find some issues in your applications, in your Spring applications. We hope it will be useful for all the Spring developers, and we collaborate with the Spring team about that as well, and take the advisory from them. But before we go and dive into Spring topics, I would raise a question, like maybe people will type in the chat, how often do you have to debug? Like, do you, like, let's virtually raise the hands, like, do you have to debug once a day? Like, some hands go up probably. And do you have to debug at least a couple of times a week? Some more hands go up. Do you have to debug at least once a week? More hands go up. And Roma is like all hands and legs and whatever. So it seems you have to debug a lot.
I
But
too.
if you like just think about it a little bit, think about it. If you have to debug something, then it's already too late, right? Means that something terrible has already happened, or you don't understand how the application works, or you have a bug in the code and you're trying to fix it, or whatever else. So debugging is not something that is super productive, like in the daily work. Probably needs to be replaced somehow, but it depends on your, of course, on your use case, on the application that you are working with. Maybe the code base was written by someone else and it's never perfect, and maybe it has been written by yourself, but it has been written like 10 years ago and you have to debug your own application. And well, before we go to Spring again, I want to reiterate on some of the very useful debugger features that are available to all Java developers in IntelliJ IDEA. And but why? Because it actually is a foundation for what we are building for Spring, and it's very useful, and it's good to know about that. And a lot of developers don't actually go beyond setting a breakpoint. And in fact, I'm going to start with the breakpoints. So well, how much do we know about the breakpoints? We know that we can set the breakpoint at any line, and the application will suspend the execution, and we can observe the state and whatever else. Like, let me demonstrate that on a slightly more complicated, contrived but complicated example. In any ways, like, we have a stream of lines and like stream of strings. We read those strings in, do some transformations with them, and so on. And when we run such an example, or debug it, run in a debugger, we hit the line. And well, what if we need to inspect the state of all those individual expressions in the line, right? So this was the time of Java 8 when everybody started using lambdas and streams and were eager to write everything in one line, and then they figured that, it's actually very hard to debug. Then we gotta set all those individual expressions into separate lines so that we can set a breakpoint. But what if you have to debug this kind of a legacy code that is still writing everything on one line and you cannot format it properly? In this case, IntelliJ will actually detect that there are multiple expressions on the same line and will allow you to set the breakpoints into all of those individually. So if we let the program run, we hit those steps in the pipeline one by one. We can, jump over through those steps one by one and so on. It looks nice, looks neat. We can inspect the state of the Lambda. We can step through the logic of the Lambda blocks if they span more than just one line. But it might not be actually the thing that we really need. The thing that we really need in this kind of situations is probably something else. Let me remove those breakpoints from the middle of the expression. When we hit the line like this, we actually, what we want to debug in most cases is understanding how the data is being transformed and how the data flows from the beginning till the end of the stream. And for this purpose, we have a trace current stream chain action that can visualize all those expressions one by one. And we can do it in a split mode and see how the first operation filters out something, how the second one filters out something, and so on. The reason we hide this operation is that it is not actually a simulation. It is an actual execution of the code and visualizing the data that was read into the stream and processed by the stream, and therefore just visualizing of this pipeline would cause the side effects if you have any in the code, right? So if you open a database transaction, then during the evaluation of the stream, the database transaction will actually start, and that's why we are hiding this. Nevertheless, it's a useful functionality in some cases when you work just with the collections that don't have any side effects. Great. So we know about the breakpoints. We can set the breakpoints at any line in the code, and we can stop and inspect whatever the state of the program is. However, there is more that what we can do with the breakpoints. For instance, we can set the method breakpoints, and historically, people try to avoid them because they make the application slower. The code runs interpreted, and it's just inconvenient. And in many cases, you don't. If you set a method breakpoints, it means that you don't know when it's going to be executed, so you're just waiting for it to hit. Okay, but in IntelliJ, for about 10 years now, the method breakpoint is actually emulated, meaning that it's not a real method breakpoint. It's something that emulates the behavior, but the real execution of this breakpoint is not interpreted. It sets the synthetic line into the method and sets the line breakpoint instead. But for many use cases, let's say for the majority of the use cases, you never actually need the real method breakpoint, and the synthetic one is just enough. So what is the use case here? We have an interface, and I have set the breakpoint for a method. Let's briefly switch to another one. And we can see that this bool method on an interface is going to be intercepted. So what is going on here? We have a factory that returns a base interface implementation. So it means that there could be multiple implementations of that interface, and we want to intercept the invocation of that implementation no matter when it's called. So we're gonna set the breakpoint right here. And if we run this or debug this program, we can see, aha, the method bool of this inner class has been executed, and we intercepted that right away. So, and the execution is right here. So we are calling it from the main method. But if we didn't know about this functionality at all, this alone is not very impressive, because if we know where the method is executed, we can just set this breakpoint right here, debug the program as usual, do a step into, select the method, where do we want to go, and jump to the same location, just the good old way. But what if we have this situation where we definitely know that some code is being executed? We know that this method foo has been invoked, but the static analysis does not reveal that that it's even used anywhere. As you can see, IntelliJ is telling us that method foo is never used. How come? What if? How can we debug this situation? So of course we can set the method breakpoint right here and run the debug again, and we can see that method foo has been invoked. And why? Why is that? Like we have a static analysis tools that could reveal the use of that foo method, but well, Java is somehow a dynamic language, isn't it? If we look at the execution point where it was invoked, it's a reflection call. And the reason the static analysis didn't find the invocation of that foo method is that the name of the method itself, the constant itself, is a result of an expression. So f plus oo results in foo, but the static analysis wouldn't be able to find it. Okay. So, and just for you to understand how smart IntelliJ is, actually, if we have it as a constant inside the get method invocation, then IntelliJ would find that. If I call find usages, it will detect the invocation. Anyways, the method breakpoints are very good tool for intercepting something, and that something could be any method in the JVM that might not have even the source code. It might just be a generated class, some random arbitrary bytecode that has been generated during the operation of the application by some framework, and whatever else. What else do we have there? We have breakpoints that can do something, but not suspend the application execution at all. So imagine this situation here where we have a behavior, or like the class, the cache class here mimics the behavior of a singleton. Basically, if the instance is null, then we set the new instance of the cache, and if it's not null, then we just return this instance, right? So if we just run this code as is, we will see and we will confirm that it's the same reference, it's the same object instance every time on every loop. What if we need to debug this part of code right here? We want to step into this a block of code every time we reach this if expression, right? So normally, naively, what would happen is that I set a breakpoint for the first time here, I hit this breakpoint, and when I want to repeat that, I would have to set the breakpoint right here, run the program. On the second iteration, I'm hitting this if condition, and to get into this statement inside the if block, I have to set the instance to null. So I can definitely do that. You probably know the evaluate expression dialog, where you can just type expressions and whatever else, like set the instance to null, evaluate, the instance is now null. So I can let the program go and hit that breakpoint of interest inside the if condition, right? So I have to do that every time. And that might be annoying. What if I automate that? And I can automate that using this breakpoint. So instead of suspending at that breakpoint, I'm going to say that it's going to be a non-suspending breakpoint. It turns yellow, as you can see. And then in the evaluate and log text box, I write the same expression, instance equals null, done. And when the breakpoint hits that if condition, the instance is set to null, it evaluates to true because instance is null, and we hit that breakpoint inside the if block every time now. So like if I just iterate, you can see the counter is changing every time, and I'm every time hitting this breakpoint. And in the output, if I just remove this, in the output, I can see that all the instances are recreated every time from scratch, right? So because I'm hitting this breakpoint or hitting this line every time. Nice. So we can automate stuff with the breakpoints. And the last thing that we can do with the breakpoints that I want to show right now is being able to set the dependencies between the breakpoints. And how can we do that? Imagine this situation like the complex workflow. By complex workflow, I mean you receive something, some data from somewhere. Maybe it's your application that receives the data. Say it's going to be an ID, like in this example. And when we work with this ID, we pass it to a method invocation that passes it to the next invocation, to the next, to the next. So there is like a long workflow, like step 1, calling step 2, step 3, output method, and so on. At the very end, we don't even remember how did we get here. So of course, there are tools in IntelliJ that allow you to analyze the data flow to here, and we can go and confirm that okay, there is a fork in the code, like there is a split. We started from the process method, and we can analyze that vice versa as well. Now imagine the situation that we want to debug this method, but we only want to debug it when the step 4 is called, but step 3 is noisy, invoked many times, and we want to skip the output method invocations if they come from step 3 or via step 3 branch of execution. In this example, it's very easy. I could just set the breakpoint here, disable this one, hit the breakpoint at step 4, and then enable the output method breakpoint, and then proceed the execution. Then it hits all good. In the real life, those branches are more complicated, and we might not want to do that exactly the same way. So what can we do here? We can set a breakpoint that will be a non-suspending breakpoint, and the fact that this breakpoint was hit, the fact that the program has passed this execution of this line, will be registered inside the debugger. So it's just a flag for us right now, the existence of the breakpoint. And on this breakpoint that we set in the point of interest, we can say, okay, now this breakpoint can be disabled until the previous one hits. So disable until Java, the complex workflow.java line 21 hits. Good. So that's the line 21. As you can see, the icon for the breakpoint is different. So line breakpoint is dependent on the line 21, and it's disabled right now. So if we execute the breakpoint, the program, we hit the line of interest, we can see the breakpoint disables again because that's the setting in the configuration. But we can also confirm that it has passed the execution of step 4 and not step 3. So what we learned right now is that we can set the breakpoints and conditions between them, and then also dependencies between them, and we can configure them as non-suspending and run some arbitrary code inside the breakpoints. That's the foundation of what I'm going to show next. If there is any questions in the chat, Roman, you just are free to come in and interrupt me at any point of time. Meanwhile,
sure. As you asked.
Yeah.
So there is a question from Henry, and the question about setting these breakpoints, as you're describing. So for the race condition, is there any way to simulate the conditions for easy debugging?
Simulate the conditions. I think for normal business logic, it's better to write unit tests, honestly. But I'm not sure if you can. Well, technically, if you extract some utility code into this stateful, classes where you can access the state of those utilities. Let's say you have some Boolean flag in there, right? And you hit some line, you set that Boolean flag to true, and then in the next location where you want to check the condition, you actually use that flag in the condition of the breakpoint in here, because that's the condition, and technically all the class path is available here as well. So you can actually invoke any static method in here and check for the result, and that is going to be your condition. It's not that something that you probably would do every day, but technically it is possible. Hope it answered the question.
I do hope as well. So no more questions for now. Yeah, and I will interrupt you with any more questions. Thank you.
Perfect. So let's look at the Spring project right here with the new knowledge that we just have learned about the breakpoints that we can set, non-suspending breakpoints and so on. And I will just close this other project because we don't need that anymore. And I will run the application. As you can see, it's a Spring project, a Spring Boot project based on Gradle. It's in Java. It has a few controllers, some debug functionality, a model, and so on. So let me just run it for now. No, I will just debug it. Sorry. Yeah, I will debug it. And now I will combine some of the things that I just showed you in this endpoint, right? So we have a trace endpoint where we have a workflow that starts the process and passes some kind of a parameter inside that process, and then we have those steps also. So I just copied that file from the other project that we just seen, where the ID is passed through the invocations. And I want to trace that, but I don't have a tracer. So it's just an exercise that I want to apply in a real life-ish application that is based on Spring, and see what else I can do. So what I'm doing here is that I'm going to set a line breakpoint. Let me see. Breakpoint. Yeah. So we have a dialog where we can see all the breakpoints in the project. And I told you that we can set the breakpoint to any method that even doesn't exist, or it doesn't need to have sources. So if we set the line breakpoints, Java method breakpoint, for instance, on a class, we need a fully qualified name of that class, workflow, for instance, and then any method, right? It could be also star. So if I set that, I will actually get this method breakpoint right here, right? Unfortunately, when you do that, when you already create that entry, you cannot change the pattern. So if you need another one, you actually need to create a new one. But as you can see, the pattern is exactly as I was typing. So any package name, workflow, any method invocation, and that's going to be a method breakpoint. So if the workflow class wouldn't exist in my sources, but was created during the operation, maybe as a proxy, then this method breakpoint would still match the name and everything. Then in the evaluate and log, I'm going to invoke a static method that is just, it actually generates the stack trace and takes the top of that stack trace, basically the location of that breakpoint. I'm going to show you the definition of that method in a second. And the other thing is that we are setting it or configuring it as a non-suspending breakpoint, meaning that it will not stop the execution. It will just record or evaluate the expression and proceed on method entry. So what is that tracer that I have there? It's just for my own use, right? So there is a trace line static method that just collects the stack trace and takes the second frame from the top, basically the point where the breakpoint is. Okay, so if we go into that page and run the trace, interestingly, we can see the stack trace collected through the execution. So even though we didn't set the breakpoints right in the program, right? So if I go to that workflow class, once again, you cannot see any breakpoints right here. So imagine if my tracer was just a plugin for IntelliJ for the debugger, you just run your application in debug mode and get that trace for free. You don't have to implement anything. You don't have to set any breakpoints or write system out print line statements. I just collected it for you and I'm just printing it out for you. Of course, if I have to execute this, like the execution, if I repeat the execution multiple times, the trace is not cleaned up. Maybe I want to clean it up, so I would have to set the, let's say, some other breakpoint right here, a non-suspending one, and do something like this: trace calls clear, yeah, don't need that. And if I run those traces or execution again, you can see it's recollected every time the collection is clean, so I don't have too many traces in memory. Okay, that's an interesting exercise, but how is it related now to Spring? So we are in a Spring application, of course, that's how, but not directly. All those breakpoints can be used by some other plugins as well. And one of those plugins now is Spring Debugger. So if we go to the marketplace and find Spring Debugger, right here, it's installed. It activates automatically, right? So it actually will set the breakpoints into the interesting classes inside the Spring framework itself that we know. We register ourselves inside those places, we collect the data, we monitor how the beans are loaded and so on. And now we can help you visualizing something. And let's take a look at the application that I have. Here it is. So I have an application where the account name is undefined and the display name is a dummy account. And if I reload the page, it actually changes. We have some other functionality in here that we are going to discover a little bit later. So one of the first things I would like to fix is setting the account name, right? Maybe the account name should be something like my own username or something like this. And let's take a look where the undefined is in our code. Let's search for that, right? This is the natural thing to do. Oh, undefined is not found. Let's take a look. Maybe it's just a concatenation of the strings. No. So undefined, no, we cannot find it. What can we do? Let's take a look at the index.html and our account name label. Maybe we can find it like this. So that's there. We can see it's a name placeholder. and navigate to the place where it is set inside the controller method. And well, it's coming from the developer name. It's read from the properties. So that's the field. And as we can see, the property name is injected. So if we go to that location, oh, there are multiple locations. So the application is somehow complex one. So we are obviously running in a debug mode, in a development mode. I think it's definitely not production or test. Intuitively, I will go to the development environment. And indeed, see here, I have something that looks like an inlay label saying that the value is undefined, even though I didn't see it in the source code. So the value must be coming from elsewhere. And where is it coming from? So if we hit that link right here, we find ourselves in a place that is called a first day prank processor. So someone made a prank on me and just reversed the string. So that looks very much like undefined, and developer account is the property name. Nice prank. But how is it activated? Okay, there is the registration for the Spring Factory, and if I click that, I will actually navigate to the location where this first day prank processor is registered. So obviously I don't need that one. I want to remove it and restart my application. Now it should work probably, or should work differently. Let's see. So meanwhile, I can check the run configuration. Run configuration. No, edit. Run. Edit run configuration. Yeah. There it is. It's Anton. I didn't clean it up, so the developer profile, this one does not exist, but the developer dev profile does exist. So when the application is running, let's check our properties file again. Oh, nice. See here, the property files that have been loaded into the application are highlighted. They have this green nice circle on the icon, and those that have not been loaded are grayed out. So we can just ignore them for now, and we can confirm that the developer profile is activated, and this is where we expect the properties to be loaded from. So if we go here, we can see, now this dev is the property value. And if you go here, dev. Okay. What if I create my own profile instead of this development profile and set my own name in there? Anton. I should see the my name in there, right? So if I go to the application screen, needs to reload, I guess. Yeah, but it's still dev. How come? Why is it so? So if I go here again, I can see Anton, and that's the value, the previous value, right? It still comes from the development profile, the properties. But if I click on this link here, I don't navigate to that properties file, to the other properties file. Instead, the message is telling me that this developer account property is defined as an environment variable. Well, Spring has this nice notation that the application property with the dot normally is the convention, right? Developer dot account is the convention. It maps to the environment variable with the notation of all caps, and instead of a dot, there is an underscore. So This one means that someone has set the environment property for me. And if we go to the configuration settings, we can see, there's a developer account environment variable that is a culprit here. Okay, I don't want it to be set, so I disable that and I restart my application again. And I hope that the real correct parameter is going to be set. And no, it's a failure again. It tells me the value dev is the real one still. So I'm still fighting my application. Why is that? Well, maybe someone has already guessed why is that, because if we click on this link, we can see the developer account has been loaded on top of my custom profile. And this is because I have configured it so, because the Anton profile has been specified before the dev profile, and whatever profile comes last actually wins. So if I change the order of those properties, you will see that finally we will see the correct username. Great. So nice. So finally, we know that where to specify it, and we know the resolution order of those properties. We know that the environment variable overrides this property file's properties, and then there is also the factory that can override it. So we just discovered how Spring operates and how it resolves properties by debugging it. Another thing that we want to help you to do with the properties is that when you hit the breakpoint, let's say we had hit the breakpoint somewhere here and reload the page and stop here. You know this expression evaluator already, right? You can run and evaluate any expression inside the watches view or in a pop-up as well. But we give you this flip, the switch to evaluate properties, because Spring is such a complex framework for configuration. Even though the application.properties file is like fairly empty, there's just one parameter. In fact, there are thousands of different parameters for the framework that have a default value, and you can evaluate them and see where those properties are coming from. So you can actually ask to detect the source of that property and navigate to the location where it is defined. Okay. So the other, let me remove this breakpoint for now. The other place that we wanted to fix was this display name, right? It changes. I want some other display name to be in here. So we have some functionality for the resolver, for the name resolver right here. And that display name resolver is an interface. And if we go to the project view, in the package, we can see many different resolvers. And the same way as with properties, we highlight those beans that are loaded right now into the application. And those beans that are not loaded are going to be grayed out, so we can narrow down our search for the real implementation of the bean that we are looking for. So it seems that there is this mock display in bean, and it's marked as primary. If we move this annotation into simple name resolver, because as you can see, this one should be activated, right? Should be the primary bean. And I would say that Anton is my name here, Anton Arhipov, and restart the application. and go to the screen right here. 1, 2, 3, 4. Yeah, it takes time to restart, but now we have a correct display name. So what we have just seen is that the Spring Debugger helps you to, observe what beans are loaded, and it helps you evaluating the expressions with the beans as well. So if you set the breakpoint to the same location where we had it previously, let's say right here, and we rerun the page to hit the breakpoint. Next to the Spring properties, you can also evaluate any beans expressions, even if those beans are not reachable from within the source code. So if we are staying in the home controller right now, we still can reach out for the, entity manager, for instance, right? And write some queries against the database from somewhere, right? So just to evaluate the expressions and evaluate the state of the application, maybe interact with the database, maybe interact with some other services even. So those expressions are pretty useful. So the next thing that I want to explore, or the last thing rather, because we are running out of time, is debug the database related functionality. So when first of all, like, one of the problems that people have with databases is that they forget to configure the data source, and then it's very hard to reach out for the data when the application is already running. And one of the conveniences that we have in Spring support is to create the data source from the properties. But as you can see, the properties for the database are not even defined here. So they were picked up from the environment automatically. And now if I want to create the controller, I don't have those convenience controls in here to press the button and create the data source instance. But when the application starts up, we can actually detect that. We can detect that the application is running and the connection itself, and dynamically register the data source for you so that you can browse it. It's very convenient in this situation when you're just running the application, but when you're debugging the tests, for instance, when you're debugging the test with the database and the test is failing for whatever reason, like maybe the customer, let's see if I have it, customer service test right there. So there's one test failing that is telling me that it fails to check the size of the collection. And when it fails, so let me run it for you and you will see that it fails. It uses the test containers to run the database. On the test start, it will start the database, run the application logic, run asserts, and then stop the test, and the database will be stopped as well. So you see this test is failing, but we cannot check the database because it's already stopped. We don't have any link to that table right now. So if we set a breakpoint right here and try to debug this test, just in a second when it starts, we will see that it will register the data source for me right there. So now we can actually go and check what's inside the table. So the customers table is 4 rows, and that is why it's failing. So, and the test expects that there is 5 or more rows in the table. But this is very useful to inspect the state of the database that you can stop in the test. You can pretty much automatically reach out for the database table and see what's inside. We have more functionality in the plugin, more advanced functionality that I will not cover today, I guess. Or do I have a few minutes more? Roman, are you there?
Yeah, you do.
Okay, perfect. Then I will show the last thing that I thought is not going to fit, but it's going to be there. Are there any questions, by the way, meanwhile?
There are a couple, but let's move them to the end of your talk.
All right. So the application, let me run the application. I will have to demonstrate how it fails. So yeah, let's start the debugger. The last functionality that we are going to touch in here is the support for debugging transactions. So in this application right here, I have a button to add a random customer. When I hit it, I will see that, okay, I will see that the application just hangs. It just scrolls the wheel, nothing is happening, and apparently there's some kind of a deadlock, right? We don't know exactly what it is. So maybe we could try debugging it. And if we go to the, if we go to the, to the view, we can see where the add random customer functionality is invoked. So we can navigate to the controller right here, and we can see that the transaction level service starts a transaction, some kind of a chain of transactions. And if we go to the project and explore it a little bit, we see that there are multiple transaction levels involved, or like multiple transaction level services involved, and everyone is calling the next one and the next one and the next one, and then finally someone creates the create random customer, and we finally hit this save method on the repository, and well, eventually it will be invoked, of course. So what if we set a breakpoint right here? We can go back to the application. It timed out already, as you can see, because, well, nothing was happening and there was a deadlock. And if you go and hit that button again, we can see that the save method is going to be invoked, and there are some additional information, hints that are added as inlays in the editor, but we can observe the same in the watches view. And the very first thing there, you will notice a different icon, a transaction attribute right here, right? So the database icon, we have a transaction attribute, and there is some metadata about this transaction. So first of all, like some attributes, right? We see the first level entity cache that is empty right now. The propagation behavior required, meaning that every time it starts, it requires a new transaction. The isolation level, and we also can navigate to the start, to the point in the code where this transaction has started. So if we navigate here, we can see it's the transaction level 1 service, and that's the method with the transactional annotation. And if we go back to the place where we are, in the source, we can see that, or in the stack trace, we can see that the process transaction level 4, where it was invoked. Interesting. So the fourth level of transaction is actually invoking that. If we proceed further and let the program run, I'm hitting F9 right now. We hit the same spot again. So apparently the create random customer has been called twice. That's kind of indirectly confirms our suspicion on on the deadlock, right? So the create random customer has been called twice, and maybe they're fighting for the same resource. Now the transaction attribute in the watches view looks a little bit differently, right? So there is a transaction, but there is also a parent for that transaction, for the logical chain of those transactions. And the propagation behavior has also changed. It's different. Now it's requires new. So remember, it was requires, and now it's requires new, meaning that somewhere in this chain of transactions, we overrode the metadata for the transaction, and we can actually see the parent where it all started in the level 1, but for the current transaction it starts in level 5, it seems, right? So you see there was a chain of transactions. At the very top we started a new transaction, and somewhere in the middle we started another one, and now they are both calling the same method, fighting for the same resources, and locking down on the invocation or the execution of the SQL statement, of course. So it seems like a bug to me. Probably could just remove this attribute. And yeah, I probably need to remove this excessive invocation from level 4. Let me restart the application just in case. No. Okay. So the application is started. We go back to it and hit the button and hit that save method. I hope it hits only once because we have removed the excessive call. And what else is here is that we created the customer in the code, right? We have collected all kind of attributes, and now we are creating the new customer right here. And when we look at the transaction, we see that the level 1 entity cache is empty right now. But when we call the save method that was supposed to be called only once, we can detect that now it's a managed entity, right? It's a managed entity. And now we can also see what's inside the level 1 entity cache. And we can see the same entity as well. And we give it, of course, we give it the nice database icon because we can detect it's an entity, not just a simple class or anything like that. So just to reiterate, what we have in the debugger helps us a lot for building the new support for Spring Framework. And the plugin that we are developing is called Spring Debugger. It's right here. We plan to merge the plugin into the main distribution as well when it stabilizes. And we have a lot of other ideas, what else we can debug and what else we can support in Spring applications, and maybe even expand this support to other frameworks as well. I hope it wasn't the time wasted for you, and thanks for listening.
Thank you very much. This virtual applause goes to you. I will applause for everyone here. I see a lot of great feedback. Thank you very much for the presentation, and for the follow you and follow your presentations for quite a while. And I think I heard your presentation about debugger like 7 years ago. I mean, one of the first presentations, like how to use IntelliJ better, and some bits were like from this, but then I was really impressed that you can create data source right from the debugger. That's great.
That's nice functionality.
Awesome.
I really like it. I even forgot already when was the last time I had to register the data source myself.
Yeah, that's awesome. So we let's just reiterate because we have this question. So guys, this is plugin. You can go to marketplace and install it to your IntelliJ. But Anton, maybe a question from my side. So with this new how to call it properly, it's not versioning of IntelliJ, but new way how it will be delivered to people, like with this merging of community version
Single distribution, you mean?
Yeah, thank you. So how will it work with this? Will plugin work with open version, or will it be available only in the single distribution under
It
license?
relies on Spring support, and therefore it's part of Ultimate distribution.
Okay. Yeah, thanks for the answer. So we do have questions, but they're not related to your presentation, but mostly like people are asking if they can have the same deep dive for Webflux or other reactive Java debugging.
Maybe they could. We do have some support for Reactor, for Project Reactor. Unfortunately, or maybe fortunately, I'm not a guru in reactive programming myself. But maybe we can organize that one day.
Would be awesome. As a person who worked for quite a while with reactive frameworks, yeah, that would be awesome. Also, I have a question about like a Scala debugger, but I'm not sure if we should proceed with that.
I cannot really comment on that because I haven't been debugging Scala too much. Generally, because it's a JVM programming language and everything debugger related is rather like a normal functionality of the debugger because it's just JVM. There might be some specific things for Scala, like I don't know, maybe generated code to be presented more conveniently, but I really don't know. I didn't have luck to debug Scala.
Yeah, no worries. So yeah, guys, please ask us questions when we have a talk about debugging Scala in IntelliJ. Thank you very much for your questions. Anyway, so yeah, I don't see a lot of questions. The most of like a great overview. And thank you very much for the presentation. And I just go through all these comments. So maybe last comment from my side. Not a comment, but a question. So for last decade, I'm fighting with the question which a lot of people asking me, and I'm pretty sure you too. It's like, why shall I buy Ultimate IntelliJ? And I'm always trying to convince people that you see how cool features are there, but I don't know. Maybe I don't have words to convince them. What do you think? Like, what is your answer?
I think we don't have an ultimate answer for that at JetBrains ourselves, or at least me. It depends on your workflow. If you're just developing Java applications that don't require any web support, not working with the databases, not relying on some let's say you don't need profilers or anything specific, then you will be good with Community Edition, right? In the enterprise projects, you often have to work with cross-technology support, or cross-technology projects, including databases, web frameworks, Spring as such, and more. And very often these pieces on the different layers are somehow related. Let's say a property inside a view is actually mapped to some controller parameter or something else, and we offer the full stack analysis for that, so that if you create a new property, then we can notify you, okay, this property is not used in the template, or you're adding new property in the template. We tell you that this property was never set and it's going to be yellow. And this kind of small conveniences, of course, it changes. It changes in a way that a lot of people now even don't look at the code and generate it using some modern tools. But let's see how it turns out in a year or two.
I fully agree. And yeah, even people generate that, but then they need to debug that to find the problems. Okay,
Exactly.
Thank you very much, Anton. It was a pleasure to have you on our conference. Thank you very much for being part of Java On.
Thanks for inviting me.
Thank you very much. See you. Bye.
Bye-bye.
Okay, we are proceeding with our conference. I hope, guys, you enjoyed that and still enjoying. Thank you very much for being with us. Thank you very much for your activity in the chat. As I mentioned several times, it's really pleasure to see your comments in online. It's really hard to really understand that behind the screen there are people. So thank you very much for posting your comments, your thoughts, your questions in the chat. This is really, really, really awesome. Thank you very much for that. So before we proceed with our next speaker, let me remind you that we have some activities which you can take part in. So one of them is the challenge in Kahoot. I already posted link several times. I will post it right now as well. So inside this link, you can find some nice stuff, and you can answer some questions and win JetBrains license. So please take this opportunity, and you will be able to use these nice features which were just shown by Anton just recently. So we are moving to our next speaker. Let us check if he can hear us and see us. Again, welcome to Java On Conference. Tell us, can you hear me? We can't hear you still, so yeah, let's take a bit of time to fix these problems. So guys, please let me know what do you think about our conference? How is it for you? Please write in the chat. Do you like it? What do you think about our talks which we heard already? And tell me maybe what you want to hear next year's. Of course, we would have a feedback form which you can fill after the end of the conference, and we always eager to hear your opinion, even if it's good or not very good. So please use this opportunity to let us know your opinion about our conference. Also, while we're waiting, let me briefly share my screen and and show you that that here on the page, on the Bear community page, you can go to the talks. You can go to any talk. For example, last talk was from Anton, and here you can rate a talk. You can put some stars here. This is really available, so let me do that. I would put 5 stars. I really like that. Yeah, we have 5 stars, which is really good. So please do that. Also, we had previous talks here, so for that you can also put the rates here. And also for people from EPAM, for example, Tanya from EPAM, you can send a badge. You can rate her here as well and say thank you, send a badge. That's always a pleasure to receive a badge right in the conference, because feedback loop is quite take some time, but here is quite fast and you can do that right away. Also, let me show you that here on the page you can find everything which we are talking about. So if you scroll down here, you can find our retro quiz, and here you can just hit play button and join it. You can find all our agenda, and all information, everything which you want to know about our conference, or even you don't want to know about our conference, but you still can find on this page. So let us check with our speaker if everything is work right now, or still not really. So I assume not yet. I assume we'll still have some technical issues, so I'm sorry. I'm sorry for that, but still, let's do some small interactions anyway. So guys, please let me know what do you think about the conference. So let's do small talk. Please write in the chat your thoughts, or maybe you would like to ask about some topics which we need to cover for our next conference. So I'm eager to talk. I'm eager to talk and speak with you. So please let me know how it's going and how it's going your day. Yeah, conference is great. Topics are interesting. Well covered. Thank you very much. Good so far. Well, I do hope that we would do our best in the rest of the conference as well. Thank you very much. As I mentioned, it's a pleasure to read this feedback. Also, by the way, the question, this year we changed the mode how we and how you register for the conference. So previous year it was registration for the whole conference, where you have this big bunch in your calendar which block whole day. Now this year we did a different registration. Now you can register per talk, so you would have not registration for whole day, but per talk. So what do you think about that? Do you like this? Don't you like that? So please let us know what are your thoughts about this thing. So far, the conference has been great. Tatiana's talk was amazing, and Anton's incredible hints about IntelliJ idea were truly impressive. Great to hear. And yeah, to feel this pause, also we have Tatiana here. Hi, Tanya. Welcome back.
Yep. Hello. I do hope that you hear me already.
Yeah.
So, guys, while we are waiting, again, one more point from us, since we would like to involve you somehow into the upcoming talk. Could you post into a chat which exact Java 25 feature you have already been inspired the most? So basically, what is the most remarkable one from your standpoint? Because actually, I can understand that not everyone might do some research around that already, and we do have quite a lot of stuff from previous versions of JDK. But from your standpoint, what is the most interesting? If not in the latest version, but in several latest versions, let's see. Because, yeah, possibly you might not have a chance to fully discover the Java 25 itself yet. By the way, an interesting year. 5 years of our conference, 25th version of Java, 30 years of Java. So many beautiful numbers. That's actually a fantastic coincidence.
Yeah, we
Whoa.
have some questions about not the questions but proposals for the topics, like please Spring 7 and Spring Boot 4. Okay, we can take that for the next year, and they will be already released, I assume. Yeah, Spring 7 for sure. Spring Boot 4, I'm not sure what is the release date, but I think next year it will be here. So when is next conference? Next conference is in a year.
At least we hope so. And
but
basically, it will depend on you. We are waiting for your feedback. And in case if you guys are ready to continue looking forward to hearing from us, we will be definitely happy to deliver this amazing conference for you, because our main reason while we do this, like besides definitely our own fun, is to bring a lot of fun and a lot of informative and interesting and useful content for you. So hearing from you what exactly you're interested in definitely helps us a lot.
Yeah, sure. And yeah, we'll have a comment that seems like someone forgot to pray for demigods. Well, guys, we are live, right? We are here in live, and everything can happen. So we try to fix microphone of our next speaker, and yeah, we try our best to do that. Meanwhile, we have an opportunity to talk to you, so which is also good.
Yep, and actually, guys, the live presentation is always about expect and unexpected, and possibly we might have a separate talk which will be devoted to what we had in background and how we resolved this. So I would like to say that you see only the tiniest peak of this iceberg, what's happening during the organization and what could go wrong and what actually did go went wrong.
Yeah, and by the way, if you want to be a part of our org team, you're very welcome.
Yep,
We always want
absolutely.
new hands. So if you want to join us in this nice adventure of organizing conferences, you are truly welcome. Also, yeah, I just have something in my mind to say, and then I completely forgot that. That's also good. Okay, more topics for the future conferences. Flexible constructor bodies, instance main methods, and complex source files, pattern matching for primitive types. I think we need somebody to do some Scala overview, right?
Yeah, actually, I like that Java tries to bring the most interesting features from different languages and to adopt them, because this interconnection and like reaction to the live atmosphere around definitely makes the language better, easier, more convenient, and more durable, more useful. So definitely helps it to stay alive for longer, for 30 years already, actually.
Yeah,
So,
for sure. Also, there was a nice comment previously in the chat, I think, while your talk, Tanya. It says that with new features, Java is much closer to JavaScript now.
that's also
partially could be true.
or vice versa, taking into account TypeScript and all of that typization stuff.
Yeah.
So-
I love this more. I love this more. But, even with TypeScript, you always can write any, and then your type
break
all your
everything.
typization, become not really useful. So
Yep. Still, we have quite a lot of flexibility, and always the thing is not in the tools themselves, but in people who try to adopt them somehow. Yep.
for sure.
Still.
For sure. Okay, more topics. Yeah, guys, we're still looking for your topics. Please post them in the chat. We have a topic: flight recorder CPU time profiler. Wow, could be really interesting. Like another part of IntelliJ itself. By the way, you know that in IntelliJ you have the profiler, so you can use it directly, and you don't even need any other tools to be installed. You can just go and directly profile your application from your IntelliJ.
So that's actually a great opportunity to have all the tools set together. And one more thing, by the way, guys, I would like to remind you that still, if I got it right, we have like open sources for the IntelliJ and its ability to write your own plugins. I've actually experimented for a while with that. And basically, in case if you do not see a particular tool in the plugin list, you can definitely develop it yourself and deploy it into your version of your IntelliJ idea, which is great, I think. So the ability to develop your own means of development, that's actually a great opportunity to think differently and to understand deeper which exact capabilities you still have in your tool and you haven't, for example, utilized yet.
So just in case, again, can you hear us?
Is
Right
it
now,
better?
I can hear you. Can you hear me as well?
Yay!
Yeah, finally.
We can hear you as
Finally,
well.
it's our
So
beloved Windows 11. Our beloved Windows 11, which is not able to recognize devices properly.
And the sponsor of our post was with Windows 11 distributed.
okay, guys. So let's not waste a time. And he just dropped from StreamYard. So I do hope he will come back very shortly. Yeah, guys. So still, like this is live, and we are here in live. We try to provide you all these talks, and just as a reference, like as we have like this 5-year small jubilee of our conference, like last year. I would be fast. We go to our speaker back. Last year we have a speaker who finished his talk just in 20 minutes from 40, and then you probably see me and Tanya trying to film this pose, and that was like, "Low, okay, this is the field for experiment. Let's just improvise," and then we go.
Absolutely.
Yeah, if you want to check the recording of our previous year conference. That was fun. Okay, Evgen, are you here with us?
Yeah.
Cool. Let's not waste the time, guys. Our next speaker, Yihen Baranovsky. Yihen, good luck, and let's go.
Okay, so let me introduce myself a little bit. So I am a lead software engineer at EPAM. More than 10 years of practical experience in different domains, including e-commerce, traveling, and statistics, hands-on engineering and architecture practice in Java, cloud, data, and NoSQL. And at spare time, I experiment with knowledge management and enjoy video games. So let's dive into our agenda. It's pretty simple, but pretty packed. The first part will be a small warm-up about honorable mentions, small changes that are noteworthy nevertheless. It's about the performance changes in Java, which Java has been pursuing quite aggressively recently to catch up with computational trends of AI and ML. And the third part will be some sort of outro with more traditional adjustments in core APIs, etc. And as much as possible, I tried to support all the theory with some practical examples, which you will find in my public GitHub repository. So let's dive into it. The first warm-up will start with some security changes. First of all, it's about PEM format support, any security-related tools like OpenSSL, but historically Java didn't support it very well. It was necessary to write a lot of boilerplate code in order to work with that. But now the situation has changed, and here you can see quite a concise sample of code how to do that with core APIs. The second is about security as well. It's about the ability to derive additional case from real use cases. For example, to simplify GDK internals, to standardize them more, to expand GDK out-of-box security APIs, and to allow third-party contributors to provide custom implementations as well. So that feature was in preview previously, and now it's finalized in GDK 25. The next GP is about some code cleanup in GDK itself. So they dropped support for 32-bit x86 port because it wasn't used a lot and just obfuscated the code base of GDK itself. And a little bonus, it is associated with it, but nevertheless, it's our beloved string class, and it has some small but pleasant improvements in hash code implementation performance, which is nice to see. So now so why doesn't switch? Here we go. So the next part is about JVM and performance changes. And first of all, I'd like to mention that I tried to run some benchmarks. Here you can see my configuration, just in case you want to compare or run it yourself. And as for the GDK distribution choice, I chose Zulu 24 and 25 because by default, more widespread distributions like Oracle GDK do not include all the garbage collector options, and here we would like to experiment with Shenandoah, and Zulu includes it out of box. And the first feature to talk about here is about AOT optimizations. So that's about ahead of time optimizations. GDK 24 introduced the ability to reuse the metadata that is compiled from class files at runtime and reuse that in the form of a cache for subsequent runs of your application to boost the startup time. And now the CLI ergonomics of that feature has improved. Previously, you had to explicitly perform 3 steps. Namely, you had to collect the configuration, which listed all the class files you would like to process. Then you had to capture that list as a cache, and only then you were able to actually use the cache. Now it's just 2 steps. So basically, the first 2 steps collapsed into one command line. But what's more interesting, another GEP introduced the ability to include also just-in-time compilation profiles into the cache. No additional flags needed. It just works out of box. And soon we will see some benchmarks for it. But before that, I'd like to mention another performance-related feature. It's related to memory management. And that GP 519 about compact object headers. Previously, it was in preview. Now it's finalized. And from that slide, you can see basically what's the difference. And the difference that is that based on practical observations, it was possible to assume that JVM needs far less memory per object, per Java object, to hold all the necessary structures. And that assumption has finally has been successfully validated in GDK 24, and now we are able to use it in production to shrink the JVM memory footprint. Now about the benchmark itself. It evaluated both features we've just discussed. And here I created a small Quarkus REST API that converts JSON to equivalent YAML payloads. And I set some fixed garbage collection and memory settings. Also, I used some out-of-box management factory code to capture the startup time of JVM. And also, I leveraged the Gatling framework to measure the performance and also to generate workload to build the AOT caches themselves. The source code may be found in the link provided on this slide. It's part of my public repository. And some short summary on the results. Here we can see that startup times actually improve with both features. Just AOT itself improves by around 32%. And also, if we add compressed object headers on top, that's another 6%, which is nice. And taking into account that this is a pretty simple application, large-scale production services will benefit from those optimizations even further. And here you can see some graphics from the Gatling test. So after I captured the caches, I run a comparative 1-minute test with each setup. And here we can see that naturally the JVM application has some startup spike by around, I don't know, 150 maybe milliseconds. With AOT, it's reduced by maybe around 90. And with AOT and compressed object headers, it reduced even further. So the numbers speak for themselves. Now a couple of GAPs about the Java Flight Recorder tool feature, which is about profiling Java applications. And here we have the first feature which improves the profiling itself, the quality of profiling. Because previously, what profilers did without instrumentation, without code interpretation, they had to synchronize with threads of our applications at some save points. That introduced bias. To overcome that bias, GFR was able to make some assumptions, but those assumptions may lead to risks of crashing the JVM itself. And now this feature brings the best of both worlds. So GFR is able to leave asynchronous requests to sample the performance, and the JVM threads serve those requests when it's possible, as soon as it's possible. So less bias and more precise results. And the next GEP introduces 2 additional options for profiling. I'll show an example soon. So basically, you are able to quite easily collect traces for certain method invocations and also collect timing results. So mean, max, average execution times. And this is configured by some simple options, which you can see from this slide. And let's have a look at a simple example. The example was based on this llama3.java project from GitHub. So big cheers to the original author who did an enormous effort of porting some C code to Java. And also it's interesting that this application leverages the FFM and vector APIs under the hood to run the LLM efficiently. And I ran a profiling session to collect a profile. I'll show you one. So I hope I can zoom a little bit. So this is the GDK mission control tool, which is able to read what was recorded with GFR. And we go to the event browser. Then we filter by method keyword. And here we have, oh, sorry, it's not able to zoom. I'm really sorry who is not able to see it properly. But basically, there is a group called method tracing. And there are 2 event types, method timing and method trace. So for tracing, I used one annotation. I put it on one of the computationally intensive methods to presume that I want to see who invokes it. And we have 23 calls throughout the profiling session. And then we have some statistics from another annotation, which was put on some parallelization code, namely on 2 methods for which works with long arrays and int arrays. And here we see that minimum time is this, maximum time is that, and also we have the number of invocations and average time of the method's execution. So pretty convenient. Now let's go back to the presentation. And let's talk a little bit garbage collection. The most noteworthy feature of GDK in terms of garbage collection is that the Shenandoah generational mod is finally production ready. It was experimental in GDK 24. And the idea is to leverage the low pause, quite efficient garbage collection mechanism and adopt it for more variable workloads often seen in microservices. And I ran a synthetic GMH test. I reused the benchmark that I used to review GDK24. It compares different garbage collection algorithms under synthetic workloads. So those are pretty focused on different low-level operations like memory copying, memory reading, arrays processing, etc. So it's not very representative of actual real-world applications, but nevertheless, it's able to highlight some strengths and weaknesses of certain garbage collection implementations. And of course, you may find the source code of the benchmark on GitHub. And now let's not waste too much time, just let's have a look at some results. So as I've already mentioned, there are a couple of disclaimers. First of all, I was forced to do the benchmarks on my office laptop with lots of security software, which probably affected the results. So my laptop was under maintenance. It is what it is. And next, as I've already mentioned, those are synthetic tests which emphasize some low-level operations, and the results will be greatly different for real-life applications. So you need to benchmark it yourself if you want to see what it means for you. But generally, there was no significant change since GDK24, but nevertheless, there are a couple of outliers. Namely, Shenandoah Generational was able to improve its burst memory allocation performance. It degraded a little bit in tests that emphasize read barriers. So this is a construct related to garbage collection, how it internally works under concurrent workload in JVM. But on the upside, it was able to improve with write barriers and was able to improve its performance significantly with overall heap allocation bandwidth. And if we look at some images, it looks like that. So you may find the full precompiled report from my machine on GitHub if you want to compare it with your own results, just in case. Now let's go to the final section, which is about core API changes. And the first feature here to look at is about stable values API. The problem that is attempted to be solved is about the problem of lazy initialization and efficient initialization. And if we look at final fields in JVM, those support some internal optimizations like constant folding, but nevertheless, all final fields are eagerly initialized. So every time your object is created, every time your class is loaded, all the final fields are initialized eagerly. The alternative previously included class loader idiom, which requires an additional class per field you need to process this way, which is quite clunky and increases memory footprint. Also, we have the old and good or bad, name it whatever you like, double-checked locking, which is tightly coupled with the well-known singleton anti-pattern. And it doesn't benefit from JVM optimizations and looks weird. But another option is functional style like concurrent map compute if absent, but it also has no JVM optimizations, unfortunately. And the stable values API introduces a solution, a separate abstraction, which allows to have the best of both worlds, namely lazy initialization and internal JVM optimizations. And let's have a look at an example. Sorry. The IDE was not able to memorize the last window I opened. So let me me zoom a little bit. These are the consequences. Do this API example. Okay. We have. Let's suppose we have some sort of observability service which is akin to Logger, SLF for JLogger, but about some statistics. So it allows us to record events. We want to have one such thing per class, like we do with loggers, okay? And here we have a service bin, which does exactly that. So here we have a new construct via this table value API supplier call, and it provides us with a lazy supplier which computes the service bin when it's needed. And for demonstration purposes, I have one operation which involves invocations to the observability service and another that doesn't have that. Let's have a look at a test. Sorry, not opened here. Okay, so let's run and zoom in. So this is a pretty simple test. It initializes some mocks and expects and is meant to demonstrate what happens under the hood via logging. Let's wait a little bit. Hopefully it will be able to complete in time. We should be able to fit into our time slot, fortunately. So basically, what we do here, we make the invocation which doesn't involve the observability service. Then we do another one which involves the observability service. And then we have another login event to separate what happens. So here we have it. So the first event, the read event get by ID, doesn't touch the observability service. Then we see that when we invoke saving the customer, the observability service is invoked for the first time and the lazy supplier kicks in. So we have the observability service initialized. And then we successfully send the observability event to the observability service. So everything works as expected. Let's get back to the presentation. A couple more features. The next feature set is related to some things that make Java closer to such languages as Python in terms of ability to quickly experiment. And this is about Project Ember. It introduced 3 finalized features and another feature which is still in preview. The first GP allows us to use import statements with which target whole modules. So hopefully you remember what are the Jigsaw modules. Next, GP allows us to use compact source files. So what it means you will see in just a moment, which basically provide a shorthand for more conventional main methods with the whole class associated with it, which presents some sort of boilerplate code when we need to try something small and quick. And the third GP makes it easier to extend constructors when we do inheritance. And namely, this feature allows us to insert some statements before invocation of the super constructor. The full source code may be found on my public GitHub repo, and let's have a look at the example itself. So Project Ember, and here we have a simple project structure. The first part is about some supposedly third-party module. This is a cache abstraction, fixture cache abstraction, and we suppose that it has some heavyweight initialization logic in its constructor. And we want to introduce some validation before we do this initialization. And we want to play with this library without creating a full-blown project. In order to do that, we create just one Java file. We even don't need to compile it, thanks to some relatively recent abilities of JVM to compile things on the fly. And here we have a simplified structure which is about the compact source files. We have just function style main method. We don't need any arguments in this case, so we can omit them. We don't have to make it static as well. As you can see, we import the whole module with the third-party library I've just demonstrated about the cache. And we have some classes underneath. The first one to look at is our custom cache extension, which extends from the third-party cache and introduces some validations before invoking the presumably heavyweight constructor of its parent. And here we look for some weak algorithms in case these are used, we fail immediately. And also we introduce some validations of the cache size itself. The rest is pretty basic. Next, we have a service which wraps the cache. And here we demonstrate the GEP, which is still in preview. So basically, these are some set of syntactical improvements for pattern matching and instance of. And the goal is to make those language features work with primitive types. So now we are able to safely and efficiently validate whether a given broader value may be safely cast down to a smaller data type. And here we benefit from this feature to determine whether we are able to invoke some optimized logic for byte values, and only if necessary, fall back to some more heavyweight implementation. And this is demonstrated with login. And let's run the thing to see it works. Let me zoom. So we go to Project Ember, and we run the run bat, which I'll show as well. Sorry. So as you can see, the command line itself here, we just invoke Java with enable preview features because we want to use the enhanced pattern matching on primitive types. Then we add the module, our fixtures third-party library with the cache, some module-related configuration, and then we pass just the Java file itself. We don't need to compile it explicitly. And the logs tell us that when we invoke the service method with a small value which fits in byte, the byte implementation is invoked as expected. And when we invoke with a bigger integer value, the integer version is invoked as expected. So this is what we have with Project Ember recently. Now, the famous Project Loom, which brought virtual threads to us in the past, and now it's still working on some concurrency improvements. The first improvement, which is about scoped values, is finalized, and the structured concurrency itself, unfortunately, will be held down till the next release, I suppose. But there are just minor improvements, so hopefully it will be able to bring us some production benefits quite soon. And let's have a look, an example actually, and recap what is structured concurrency on its own. Project Loom. So here we have, suppose we have some sort of business logic which involves multiple services. So here we have some invoice service which executes several steps. In invoice processing, it takes customer ID, order ID, and language. Then it gets the customer data, then the order data, then renders the template using the requested language. And every step, as usual, requires some exception handling, some boilerplate code, which is usual to executor service-based implementations. So basically, we have 1, 2, 3 lines of useful code, 4, 5, 6, 7, and the rest is boilerplate. Not very handful, right? And if we have a look at what a structured concurrency proposes to us, it's much more compact. As you might remember, we have the abstraction of structured task scope, which is some sort of context for managing our forked tasks. It runs on virtual threads by default. It's possible to run on traditional threads, but it's not recommended for obvious reasons, because we might spawn thousands of such tasks, obviously, and overload our platform threads, which is not good. And here we fork each task from the scope, then join. So it's a lot easier than having 3 try-catch statements. Then we get the results and render the final step. Much more compact. Not ideal, but much better. And if we have a look at some scoped value examples, the easiest way to demonstrate that is on some login features. Okay, so we have a tracing static utility which holds a scoped value. So this is the finalized API. And it represents another kind of context. It's a counterpart to the old good thread locals, but much more concise and much more safe in terms of memory leaks, because I believe that every seasoned Java engineer has faced a situation when someone forgets to free thread local, and over time, memory gets accumulated, and boom, we have an out-of-memory error. With scoped values, this is much harder to achieve, because every invocation which actually uses the memory is wrapped in a nice lambda. So here we have our login service, and we attach a string with a trace ID to the scoped value. And then okay, so let's have a look maybe at the test itself to better understand what's going on. Oh, probably I forgot to add one. Okay, so basically we have a tracing utility. It's invoked from the so it's invoked from the structured invoice service. Sorry, I was in a hurry to fit in the time slot. That's why I forgot. So here we allocate the trace ID itself, put it to pass it to every invocation we have, and what happens under the hood? That trace ID is bound to scoped value and reused nicely for each thread. So this is the example. So this is all about the new features in JDK 25, which is a long-term support release, and thus you may safely migrate to it and use all the features finalized in that release. And since it was quite a long time since the last long-term support release, which is 21, let's recap what JDK 25 long-term release brings us since JDK 21. And first of all, it's about language ergonomics. This is about flexible constructor bodies. I demonstrated that in my Project Ember example just a couple of minutes ago. Next, we have some improvements to pattern matching. So this is for efficient data-oriented programming. I believe Oracle has a series of blog posts related to that concept. Then we have compact source files. I demonstrated an example as well. And also we have support for Markdown in Java documentation, which allows us to write some well-formatted comments for our code. Next, we have core API improvements. That's about foreign functions in memory API. This is important for AI because it enables high-performance computing by invoking directly native libraries and using off-heap memory. And this is without the old and unstable abstraction of a Java native interface. Next, we have scoped values. I've just showed them to you. New security APIs. So this is about different format support, new APIs for security key manipulation, etc. Next, we have stream gatherers. So this is the extension to Streams API, which basically allows us to have something similar to collectors, but in the middle of the pipeline. So they are not terminal. You can proceed with further steps of processing. And next, we have class file API, which is a replacement to third-party libraries like ASM or ByteBuddy, and allows us to have more safe bytecode manipulations in such frameworks like Spring Framework or code generation libraries like Lombok, etc. As for JVM itself, we have different improvements to performance in the form of AOT for faster startup, the new generation of Shenandoah garbage collector. I showed a benchmark to you in the middle of the presentation. And we have improvements to profiling with GFR. We've discussed that in this presentation as well. And here you can find some articles that were used during preparation of this presentation. And of course, you may find the links to my public GitHub repository on the previous slides. Thank you very much. Let's go to the questions, if any.
Thank you very much for the presentation. So even with some technical troubles, we were able to finish in time. That's great. Yeah, guys. So you can, as Egan mentioned, you can check repository later and check it by yourself. Yeah, if you weren't able to see it on the screen properly, so please do it later. Okay, so we have a couple questions. First one is related to AOT and JIT caches, and the question is, where are they located? Wondering if it gives any advantages for containerized apps.
So as I've mentioned, let's go back to the slide itself. The AOT processing involves several steps. Previously, you had to run 3 steps. Namely, collect the list of classes you want to capture. The next step to actually use that configuration to make some sort of warm-up run for your application to collect the metadata required. And that step provides you with an output file, which you can subsequently reuse in the command line arguments of the actual production run, and hopefully boost its startup times and shrink the time till optimal performance. And the next part of the question, please, Ron, could you please repeat?
Yeah, the general question is if this can be anyhow helpful or any advantages for containerized apps.
For containerized apps,
so basically
probably.
Docker.
It depends on the complexity of the application. So basically what we are talking about here is about some workloads which take time to warm up and do some optimizations to the classes, to the bytecode, just-in-time optimization, etc. But in case we are talking about some very lightweight workloads like Lambda functions, for example, in AWS, then probably it doesn't make much sense because the lifetime of such applications is extremely short, and probably the difference between the option with AOT and without will be negligible. But on the other hand, if you load a lot of classes in that Lambda function, which is not advised actually, it may provide some boost to your 99 percentile, for example, in this case.
Okay, thanks for the answer. Guys, we're still waiting for your questions in the chat. So we have some time for that. So maybe while we're waiting, a small question from my side. So as we're speaking about Java 25, which were released in September, in your opinion, when would it be time for to start migration for enterprise project, of course?
Well, I believe it depends on the frameworks and libraries you use on the project, because, for example, Spring framework, even in its latest releases, still supports Java 17, if I'm not wrong. So basically, we have quite a lot of time for major migrations. But in case you would like to benefit from the performance optimizations, for example, from GTK 24, GTK 25, it makes sense to consider the effort of migration right now, I believe.
Okay. Question from Evgeny. Thank you, Yihen. Scoped value looks promising. Do you think thread local still have use cases over new API?
Well, from pure functional point of view, they are equivalent. From safety point of view, scoped values are safer, especially in an environment where you use virtual threads, which may spawn in thousands and thousands. Because under the hood, scoped values gracefully deallocate memory associated with them once the virtual thread blocks. But on the other hand, we have a lot of legacy code which relies on thread local libraries. So I'd tell that eventually thread locals might get deprecated, but the legacy code is legacy code. So it's up to the maintainers of that code to migrate to scoped values, which is advisable, I think.
Okay. Let me just pronounce it one more time that GitHub repo will be shared along with presentation. But Ethan, if you can later go to the chat and share the link, would be great. I mean, not now, but maybe after we finish with questions. So, guys, if you have any more questions, please feel free to post them into the chat. Yeah, I don't see any right now. So I think we can wrap up on this. Thank you, Ethan, one more time. Great talk. Thank you very much for sharing it with Javon. Thank you for being part of our conference. Yeah, thank you very much.
Thanks. Bye.
Bye. Okay, we proceeding with our conference, and let us, while we're waiting for our next speaker to appear, let us go through the things which I want to remind you that we have in our conference. Where is my mouse? Oh, okay, here it is. Found it. Yeah. So let me share my screen one more time. Yeah, here it is. Share screen. Yeah. Here we go. Okay, guys. So this is the page on your community, which I'm pretty sure you're aware about, and you can check all the things here. So if you miss our agenda, you can go here, and you can always find our talks and what to expect next. So we have 2 talks more to go, and they would be related to AI and not only, well, both related to AI in any case. I hope you're not too tired from AI. So please write in the chat if you're tired from AI already, or you eager eager to know more about AI and MCP services and servers and anything around that. Also, let me remind you that we have some offline events in some of our offices for EPAMers. So if you are near some of these offices, please consider possibility to join them. Some have activities right now, today, and some will have tomorrow. So please check office nearby to you, and maybe you can join our fellow communities with their activities. Also, we have a nice Kahoot quiz, which you can still join, and we will give away some IntelliJ license. So if you want to take opportunity of using new Spring Debugger or other cool stuff which you can use in IntelliJ, or not on IntelliJ, by the way, you can choose any IDE from the pack which you want more. So consider playing this Kahoot quiz, really nice one. Nice challenge on knowing tech history and some interesting facts. So yeah, consider doing this. Just one more thing, please use your real email, because we would use it to contact you in case you win. Yeah, here is our speakers. Don't forget to go to the speakers page, for example, to the Yigen talk, and rate him. So here on the bottom, you can put some stars. Also, you can rate speaker here. Honestly speaking, I don't know why we have 2 ratings, but why not to put stars into places. And also, you can send thank you badge. So let me do that. Thank you very much for wonderful talk. Exclamation. One more. And more. Okay, cool. Let me select something. Thank you for your talk. Inspiring talk. Works great. Give a badge. Done. So you see, just a couple minutes. Everyone happy. Again happy. I am happy. Everyone happy. Great. So please do that. Please consider doing this, guys. This is really important for everyone to do. To receive your feedback instantly on the go, and yeah, our speakers are really eager to receive some feedback from you. You know what? There is a problem with future, and the problem with future that this thing is really hard to see through. So I need to take it out. So yeah, we are continue with our conference. I do hope you enjoyed it. Please write me something in the chat. We have a couple minutes. We have a couple minutes to wait for our next speaker. So let's do a small quiz. Let me play with you a bit. So let's check which version of Java you use right now. So please write the version of Java you use on your project into the chat. And let's check which versions of Java are right now in use there. So if you use any version of Java, please write the number of the version. If you use any other language like Kotlin or Scala or anything, you can put it into the chat as well. So we would see that, yeah. So I see a lot of 17. Well, great. I don't see any 8, by the way. That's wonderful. So I see 21 a lot, which is really cool. Yeah, and I see, wow, 21 and 25 at home. Really nice. Python, and sad smile. Well, that's also okay. Python is kind of version of Java. 11. Yeah, like every time I say 11, I remember this meme. But yeah, 11. Well, it's also cool. But please consider migrating to Java 17 at least, but better 21 or 25. And with saying all this, oh yeah, Dini, still 8. Unfortunately, I'm sorry for that. I do wish you would migrate to some other version soon. 35. Somebody used Java 35. I think it's some time traveler as myself from 2055. Tell us how it is there, how it is with Java 35. How is it working? Okay, so I think that we can move on with our next speaker, and let me welcome on Javon Conference Andrés Rivera. Andrés, hola, buenos días, bienvenido a Javon.
Hola a todos, bienvenidos. Gracias por la bienvenida. Hello, everyone.
Hello. So guys, if you understand our chit chat with Andres just a bit, just write something in Spanish in the chat so we would know that we are not alone here. So before we dive into your topic, Andres, maybe you can give us just a small hint. What would be your topic about?
Sorry again.
Yeah, no worries. Can you just give a small hint? What would be your topic about?
Oh, yes, of course. Today we will talk about NCP protocol servers that it's used to connect our agent AI with or to give more additional tools to our LLM models. Well, that's the topic for today. Also, a lot of conference about MCPs are focusing on Python, most of them, and JavaScript, but not most of that conferences are focusing on using Java and show how to connect our HCP services with IntelliJ.
Okay, cool. So you can share your screen meanwhile, and while you're doing so, I will ask one more time people to use our chats to asking questions. So you can do it in both English, Spanish, and maybe any other language. So I will try to translate them. Yeah, use both chats on the community platform and YouTube. I will monitor. Will and still monitoring both of the chats, and I will ask your questions in the end of the talk. Don't forget to rate our speakers and rate their talks and give badges. This is really valuable and kinda cool.
Well, let's present. Share my
Yeah.
screen. Share screen. Okay. The screen. This one. Okay. Are you seeing my screen?
Just give us a second. Yeah, we can see it. Okay. All is ready. All is good. Good luck. And let's
great.
go.
Perfect. Then let's start. Well, for today we will talking about MCP services, of course. A little about me. I am a lead software engineer here in EPAM since 2022. Well, I am a coffee lover. Here in Colombia, it's really common to find a lot of cafes, and all of them try the best to give you the best experience just in a cup of coffee. And also, I like to go to the gym every day, Monday to Friday. Well, and also about my IMAs, this was my dog, my bitch, and this one are their puppies. It was amazing to have all of them running and playing with them. Well, I guess that represents a little about my hobbies. Well, let's go to business. This is the agenda for today. We will discuss or give a little overview about what is an NCP, the core concepts, some differences with other technologies, a lot of things about security essentials, the NCP ecosystems, and later the hands-on for the last part. MCP basically means Model Context Protocol. It's a way to communicate easily with our agents AI, as I said, and to provide additional tools to our large language models. Key points about the NCPs. This protocol was created by Anthropic last year. Anthropic decided to give a license for this one as an open source. It let us or enables AI assistance to access external data or tools in a securely way. Also, the architecture for MCPs is a client-server architecture, and it's language agnostic. It uses JSON RPC to communicate with our agents. What MCP solves? Basically, LLMs are powerful, but normally that kind of models are isolated. They can access external information or, for example, business data or private data. Lack of real-time data. They don't have, before MCP, we don't have any standard way to access external APIs or files inside our laptops, our computers, or give other kind of tools, like, for example, access to specific methods that return business logic. Then, before the MCPs, this is the scenario that we have. For example, if we require to connect our large language model with YouTube, YouTube have to offer, or maybe we have to create an API to access our specific channel and provide with that information to our LLM. Or if we want that our LLM communicate with Slack and with our project Slack, for example, we have to create an API, or each of these tools were creating its own solutions to communicate with our large language model. Then, when later of that, Anthropic was thinking in a single protocol that let us communicate with our large language model in an easy way. And what we have here is our models, Cloud, GPT, or maybe Oyama or another one. Just have to know one single protocol, and our MCP translate all of that to provide with to the model with that specific tools, or to give access to that specific tools. Here, to understand the actual AI ecosystem, we can review this little diagram where the AI agents are presented as the orchestrator in the middle. The AI agents receive the prompt. This goes to the model to translate that prompt that it's given in natural language, but the AI agent requires to have that information in a matching language. Then later of that, it decides to go to an MCP server. It requires a specific tool for that. And from here, we have different MCP services that give access to different tools. For example, this one gives access to a database server. Maybe the prompt, it's about create a report about the the last or the sales month, the month sales for for the actual month, and it will require to get that information from our database. The AI agent will decide to give that information to the model and finally return a report maybe in a PDF format. Here we explain a little what are the different the different functionalities for the LLM, the AI agent, and the MCP server. As you can see, the main function for the model, it's basically processing the language, and the AI agent, it's executing complex tasks, orchestrate, finally. Here we have an example about how it works. The AI agent will receive the prompt. The LLM will translate the prompt in a matching language. It will decide the steps required to that prompt. Later, in the steps, first of all, we require to go to the database to get information about sales data. We will give that information to the LLM. It will analyze that information, generate the insights, and create a report in a format asked in the prompt. Later of that, we have to go again to the MCP, because inside the prompt, we have the order that send a report via email. Then we will use the MCP to do that specific task. And finally, we will respond to the user that everything, that the report was created and sent it by email. That is the best example for this one. Let's see what is the MCP architecture. Well, basically, we have here the AI assistants. The AI assistant probably is created by one of these ones. For example, Cloud has its own chat, GPT also, or inside our IDEs, for example, IntelliJ has also, it let us add plugins that has that MCP client. The MCP client communicates through the JSON protocol to our MCP services. And inside the MCP services, we could have resources. Resources are, for example, databases or files, or we could have tools that go against the databases and maybe add a security layer, for example. We can have also prompts. The idea to have prompts through an MCP server is to provide to all the organization with the same standard prompts, and we will see how it works in our demo. Okay, let's continue. Let's go to each of these ones in our MCP services. As I said, resources. Resources could be a database or a file, maybe messages, are only read-only. That's a big difference with tools. Could be static or dynamic, and are identified by an URI schema. And support templating for dynamic content. Let's continue. Let's see about tools. Tools execute specific operations, can modify the state. We will see what is this one in our next slide. Can return structured results. And well, here are some examples of that. For example, execute a query or send an email, as we saw in our example, or maybe create a Jira ticket or review a PR, something like that. And here it's the big difference between resources and tools. The resources can modify the state, the tools can modify the states, but resources are thinking more as read-only, required to access specific files. Then we can create here a method that go and review that specific file or access that specific file, or maybe get information from our database for a specific user, or maybe give us the log information to do an analysis about something that is presenting in production, or trying to review some or giving alerts about our applications in production, just reviewing the logs. But all of that, it's read-only. Tools could modify or could update information. For example, we can write a specific file, or we can create a user in our database, or we can cancel an order using an API, something like that. And finally, prompts. These one are just predefined prompt templates. Could include dynamic arguments. It encapsulates best practices. That's the idea, to use an MCP server to distribute that template prompts in our organization. And well, some examples are code review checklists. We can create a template prompt to do that and distribute it to all the developers team. Bug report template, architecture decision template, and other examples. Let's talk about differences with actual or with other technologies like REST APIs. Basically, REST APIs are thinking to communicate to human or other APIs, or to give integrations with humans or front-end applications or API or other APIs. The discovery, it's through manuals. The MCP give us automatic introspection. The schema used in an API is Open API, for example. But by MCP, it's always JSON schema. The context, as we know, APIs are commonly stateless. MCPs save the context of the communication. They are thinking, the MCPs are thinking to be optimized for large language models. APIs are thinking to be to communicate or for other purpose. And the standardization about APIs, it depends on the project, as we saw at the beginning. But MCP is just a single protocol. Okay. before NCPs, a way to cover or to give tools to our large language model was using function calling. Basically, for example, for GPT, they have its own SDK where we can use a specific function calling with a specific parameters. But is the way how GPT solve the problem about how to give tools to their model. But with NCP, all our models knows that we have same standard to call a specific tool. When we are adding a new tool, it's just giving the name of the tool, a schema that it's JSON RPC, and a handler that it's the function in charge to provide the functionality to our LLM. Okay. Well, here it's basically the same as I said. Here it's an example about what is function calling. As you can see, we have to do, using this approach, all LLM have to provide or have to be in charge to do all of these ones, all of these tasks. As you can see, for example, the user is using DeepSeek in this diagram. The DeepSeek has some function definitions, but there are specifically for DeepSeek. It will decide what function have to call to get the information required for the prompt, and finally integrate, get that information and generate the answer for the user. User NCP, as you can see, the NCP, we will have an NCP client here, or even better, an agent AI. And the agent AI will orchestrate everything. We'll call the large language model. We'll call the NCP servers to get access to the tools. With that information, it will send that information to the large language model, and finally provide the answer to the user. Well, let's talk about security essentials. Basically, for NCP services, it uses same security architectures that we consider for APIs. Here, for example, about the authentication and authorization, we can use a client identity by providing an API key, or using an OAuth, or using MTLLs. We can implement also role-based access control, or we can add audit logging. About the input, it's important to validate what is the input to our NCP service to sanitize that entry and prevent injection attacks. And well, we can limiting the number of requests against our NCP service, thinking on reducing costs, enhancing security, mitigating security risks, and also managing system load and scalability or prevent resource starvation. The way to do that is the same that we are using for our APIs. For example, it's adding a rate limiter here before calling the NCP service. And yeah, I don't know if all of you are familiar with this one, but for example, in AWS, it's just creating a policy to limit the number of requests to our services. That could be limited by region also, or by users. Yeah, there are a lot of possibilities, but we are using exactly what we have in the market right now, but just implemented that for our NCP services. Another thing that it's really important to have, it's about the data access control. We are using exactly the same principles. For that, we have to filter in passwords, keys, personal information. We have to have in our mind the principle of least privilege, and also thinking of respect the existing permissions. We can do that. For example, if we try to go to a database, it's better access the database not directly. Even better is go through an API that had all or to manage all the access permissions required for our database. And this one is another way to manage security for our NCP, and it proposed to have a sandboxing or to have a sandbox or to install our NCP service inside a sandbox container. It let us isolate tool execution, limiting the usage of our resources, and also we can have a timeout for our operations. It prevents, for example, infinity loops. That it's a problem when we are managing a multi-agent, for example. Multi-agent AI has that known problem. And well, this is a way to limit that or to prevent that. And this one, it's another, it's a final approach that is right now using for NCP. It's called NCP proxy. The idea is to provide our NCP services. Before go to our NCP services, we will have a proxy that will wrap all that security essentials we saw before, like the authentication, rate limiting. We can have also load balancing for our NCPs. We can add monitoring, caching. The idea of this one is encapsulate all that security essentials. About the NCP ecosystems, we have the official implementations in Anthropic. If you go to the Anthropic page here, you can see all SDK implementations for each of these languages. Also, you can go to this page and see some implementations, some great implementations, or a very good repository that had a lot of samples about model context protocol. Also, you can go to the official page called modelcontextprotocol.io, and you can go directly for a specific SDK depending of your language. For Java, for example, is this one. And also, Microsoft is doing a very good job about communicate and giving some tutorials about MCP. And it has a very good repository called MCP for Beginners. Also, it has Java examples. And yeah, it's a very good repository. Well, let's go to the demo. Before the demo, I forgot why to use Java. Well, basically, as you know, Python has a lot of information, or has a lot of libraries that are working with large language models, but Java give us integration with enterprise systems. A lot of companies are using Java as his main language. Then it's a good reason to use Java to create our MCP servers to communicate, for example, with APIs or with databases or so on. Also, Java provides us with high performance and concurrency kind of code or features. That's the word for that. And also, it's type safe. That it's as you know, it's better to have a language with type safe instead of other kind of languages. And it let us create complex APIs also. Well, now let's go to the demo. Okay, well, before go to the demo, let's explain what it's in our or how I create this demo. Well, I was using Spring Boot, but mainly to simplify some structures, like I am using the command line, for example. The communication that I will use is standard I/O. That means my MCP server, it's not always up. It's just call it when it's required, well, it was I create a custom class that provides specific tools that could be used by the LLM model. Okay, well, let's see about the libraries I use. As I said, I just use Spring Boot to make easier the call of my MCP server. This library is to provide my MCP server with JSON RPC communication, and also Jackson to translate JSON in or to serialize my the JSON's response or the JSON communication. This one is just the normal libraries for logging and also Lombok. Then, as you can see, it's quite simple. I am not using a lot of libraries in this example. Here I am explaining all of that. Let's see. Let's talk a little about what is standard I/O. If we go to the official page, we can see here some examples of what we are using for the JSON RPC. For example, if we want to return audio content, this is the JSON RPC expected. Or if we are providing with some resources links, this is the JSON expected. Also, here are other examples about that communication with JSON RPC. Okay, well, let's continue with our NCP. Here is the server, my NCP server architecture. As you can see, I will connect my NCP server with IntelliJ. The communication will use standard input-output using JSON RPC. It will call my or this class, the standard IO NCP server. It will receive some processed JSON RPC messages. And the implementations are based in this interface that it's called a base prompt that provides with some standard methods that all my tools have to implement. And finally, I return the information using, again, JSON RPC. And that's all. Well, let's see. Give me a moment. Let's see that in action. Well, here it's the NCP, I call it refactoring prompt. Here is just a configuration class. It is not doing a lot of things, just returning my standard IO NCP server as I call my NCP server. As you can see, what I will receive there, it's all the methods or the tools that my model can use. And that's it. I return JSON for that. The JSON has a name of my NCP that it's called a refactoring assistance, a version, and the list of tools that could be used. If we go to the base prompt, as you can see, it's just an interface with the methods that should be implemented in my tools. And let's see, for example, the design pattern prompt. This tool just returned a specific prompt, template prompt, that provides to the LLM with some instructions about what we require to apply. Also, it can receive or not the design pattern we want to implement in our code, or even we can tell him that review before the code, and maybe let us know what is the best pattern design to be implemented for that specific code snip. Also, if we want to apply a specific style for our code, we can create here again a prompt for that. In our prompt, we are telling what kind of styles we want to implement. For example, here I am telling him to provide the styles used by the Google Java Style Guide. And here I am telling to show the code following the Google Java Style Guide again. Also, I can implement or not with Lombok style, just sending an argument for that. And that's it. Here, for example, this one, it's applying just a style without Lombok. As you can see, we are receiving that from as an argument. And if we don't have that specific, if we have in the style only true, instead, we will apply the style format, but using Lombok to reduce the boilerplate. Here is the instructions to do that. Okay, well, let me look inside another one. This one is a dynamic prompt. As you can see, inside my prompt, I am adding some variables. In this case, just two variables, the language and the code. And it's quite simple to change that. The language will be here inside our prompt. And here is the code we want to analyze. That information is sent to the NCP server using the NCP client or using an agent AI. Okay, then let's go to the demonstration. Well, I did the demonstration using Copilot, but well, the NCP servers could be used by other NCP clients like the Gemini NCP client, the Anthropic NCP client, any of them. First of all, how to setting up our NCP client? Well, you have to go here. Let's call here a new one. Then you have to go to GitHub Copilot. You have to go to the agent mode. This one is the ask mode. As you can see, for the ask mode, it does not use NCP services. Then let's go to the agent mode. And here you will see the configuration tools or the configure tools. You can see all tools that are available for Copilot. And also here it's my assistant. Let's see here. And as you can see, I can say to my refactoring assistant what large language model I want to use. I told him to use Cloud. And well, here is save. And I forgot to show another thing that it's here. If you want to add another assistant, you need to click here and you will see this file. This file is configured for all for GitHub Copilot. It's in my home folder .config / GitHub Copilot, IntelliJ, and MCP JSON. Here, I add the information about my MCP. As you can see, it's just the name on my MCP, the command I require to run, and the arguments for that will be the instruction jar or the parameter jar, and the jar I require to call. That it's this one. Then it is called when the agent required to use it. It's not running all the time in my local computer, but also if we are using an API, well, we have to have the API running, of course. Well, let's continue and let's see. Then let's go here, and I prepare a pet project with some problems that I want to resolve. For example, this one has 2 problems. It's a really long method with many responsibilities, and also has some code smells. As you can see here, we have a lot of ifs. We have a lot of responsibilities for our method. And also, we have some problems with if annotated. It's quite complex to read this method, as you can see. Then what I want to do is to telling to Cloud that help me extracting this method in different extracting this method in reducing the complexity of that. Then from my other ones, we have this method, the extract method prompt, to be sure that to be sure that GPT or Cloud will use exactly my MCP refactor service. I can tell him to with the add with the add character and the name of my on my MCP service, and later telling what exactly tool I want to use, and that is what I will use it here. But also we can just tell in using the refactoring assistant extract method for this specific method. Then let's go there again. I will use the simple way, that it's this one, extract method. But let's just send that instruction. Let's wait for a while. Let me see what it's. I forgot how much time it takes. Okay, well, let's say ASAP. As you can see, first of all, he creates some specific constants here that will help us in extracting or simplifying this information. It creates a lot of methods inside. And here it's a more clean method than what we had before. And it separates responsibilities using different private methods. And finally, it just gives us this and log the summary, the order summary, and return what is expected. It's quite more simple. Here are all the methods that it creates, separating by responsibilities, and it's more clean. And well, that's all what I have for you in my demonstration. And let me stop the presentation, or let me go again to... Well, any questions?
Thank you. Thank you very much, first of all, for your great presentation. Great dive into the MCP and stuff. So let's, we have a bit of time for the questions. So let's start with them. Do you have an idea how orchestrate tools in case, oh, sorry, it's just dropped. Yeah, so do you have an idea? Oh, come on. Just give me a second. I will copy it because it's just jumping from the feedbacks that your talk is amazing. So yeah, do you have an idea how orchestrate tools in case when we have big amount of tools and some of them similar? For example, 200. I suppose LLM will stack on using it. One person works with one input field for everything.
Well, the orchestration is managing by agents. We can have just one agent doing or managing all the orchestration, and we have to review how we want to drive the orchestration in our agent AI. But it's something that the NCP server doesn't do. The NCP server is thinking to provide with tool resources, as I said, or prompts. Orchestrations is doing by our an NCP client, but most probably by an agent AI. It's more specific for that. Even at the beginning, I show how showing the example. Yeah, this one. Let me show this one again. Yeah, here, as you can see, the agent, first of all, goes to the LLM to get in a matching language what it's asking in the prompt. The LLM, it's well, is the unit, or yeah, we can call it in that way, is the unit responsible for translate the prompt in matching language. Then later of that, it can provide to the AI agent with are the steps expected for to be achieved in the prompt. Probably for this prompt, for example, we have analyzed last week's sales and sent a report via email. Then the LLM will take this information, separate the different steps to requires for that. First of all, it requires to get the information about the week sales, and with that information, it will create or it will generate insights and create a report, and all that steps, and finally send it that to a specific email that probably was introducing the prompt. That information is provided by the AI agent, and the AI agent will see the different steps for that. And in this part, it will orchestrate all the calls required to get first of all, to provide with the specific information to the LLM, and later send the information by email. As you can see, the AI agent await that information from the LLM at the beginning to get all the steps required for our orchestration. I don't know if that resolved your question.
Yeah, let's wait for the answer in the chat, but thank you anyway for the answer. Okay, another question we have from Vasily. A question on your implementation. How do you handle errors? Do you keep LLM in the dark and risk it instantly retrying tool call, or provided some context on what went wrong and how it should proceed?
We can provide our, let me see, I have some examples here, but we can provide, because we are using Java here, you can just throw an error, or you can return a specific message giving what was the problem, trying to return the information required. For example, I could send the email in the example that we have at the here, or we can connect with the database. We can return that as an exception if we are using Java, but our MCP server will return that information in a JSON RPC answer for the AI agent, and he has to analyze what we return for that, and take a decision about what to do with that information.
Okay. Thank you very much for the answer. And I think we're running out of time. So I want to say thank you one more time for your talk. Thanks for being part of Java On. Enhorabuena y mil gracias.
Muchas gracias. Have a good day.
Adiós.
Adiós.
Hello again. We are back, and what are you saying, Grogo? What? Oh yeah, only one talk left. So that means that you have last chance, to participate in our Kahoot challenge and win IntelliJ license. And also, don't forget, please, to go to the page, talk page, and to rate our speakers. This is really important. So please rate their talks. Send them badges, and of course you can send badges to org team as well. Really highly appreciated. Thank you very much, and thanks for being with us through all this day, quite full of talks and stuff, but I do hope you enjoy our conference, so please let us know in the chat. And we are moving to our last but absolutely not least speaker. So it's easy for me because the name is same. So our next speaker, Andres Ortiz. Andres, hola, bienvenido a Java On. Andres, can you hear us?
Hola, hello everybody. Hey,
Yeah, so
can you hear me now?
we have some. Yes, it looks better. Okay, we now can hear you. Okay, seems all good. Okay, cool. So let's let's not waste time. So you can share your screen meanwhile, and we will dive right into your topic. Meanwhile, guys, let me remind you last time for today that you can use both chats to write your questions. So you have chat on VR community platform, you have a chat in YouTube. So you can use both of them to write your questions. I monitor both of them and will ask your questions to our speakers in the end of the talk. Yeah, just a reminder again about Kahoot challenge and reminder about rating for our speakers. And all the recordings of all our talks will be available on YouTube and on our on VR community platform. On our community platform, yeah, also sounds good. Right after the conference, so you can rewatch it anytime. Okay, so Andres, good luck and let's go.
Thank you, Roman. Great. Good morning or good afternoon, everybody. And thank you all for joining me today for this exciting session. My name is Andres Ortiz, and I am thrilled to be here to talk about a topic that directly impacts how we, as developers and engineers, adapt to this ever-evolving world of technology. As many of you know, Java has been a cornerstone of software development for decades. It powers millions of applications across the globe and continues to grow and adapt to meet new challenges. But as we head toward 2030, the landscape is shifting rapidly, especially with the rise of GenAI, new frameworks, cloud computing, and other emerging technologies. So why talk about this subject now? Well, the intersection of Java and GenAI is one that has already started to profoundly change how we approach software development. Tools like GitHub Copilot, ChatGPT, and other AI-assisted tools are transforming the way developers write code. This is a streamlining repetitive tasks, helping us debug faster, and even assisting in design decisions. So these innovations are reshaping expectations for engineers and are altering the very fabric of how applications are architected. At the same time, Java continues to evolve. As we move to an era dominated by cloud-native development, serverless computing, edge systems, IoT, and of course, GenAI. Java still remains critical for enterprise tech ecosystems, but we must adapt and innovate to stay ahead. In today's talk, we'll cover the following key areas: the current state of Java and how it's shaping modern software development as of 2025, the rise of GenAI tools and the profound impact they are having on our workflows, what Java developers need to know to thrive in the next decade. We'll also include predictions for how Java and its ecosystems and the role of the developer in the 2030. I will include the main challenge of integrating GenAI with Java development, and finalize with a discussion on how you should prepare for opportunities and the risk of these technologies. So let's dive in. And before we get started, this presentation reflects my personal opinions and interpretations. This is based on real data, statistics, and research, though. The views expressed here do not necessarily represent those of any organization or entity. I encourage you all to think about how tools like GenAI have already impacted your development workflows. Feel free to share your thoughts or questions during the Q&A. And remember, we're here to learn from each other. So let's kick things off by looking at where Java stands today in the evolving software development landscape. So let's start taking a closer look at Java's place in 2025. You know, Java is a programming language that has stood the test of time. and continues to evolve as technologies advances. Java has been one of the most widely used languages for nearly 3 decades, and its versatility, reliability, and scalability have made it a cornerstone of modern software systems. But the question we want to ask today is how Java has adapted to the challenges and opportunities of today's tech ecosystems, particularly in areas like cloud-native computing, security, and of course, artificial intelligence. So in this section, we'll explore the Java's current role in software development, some key trends and innovations shaping its future, and how Java fits into the AI-powered world of 2025. First, let's take a snapshot of Java's current place in modern development as of today. Java remains one of the most trusted tools for building robust and scalable applications. And, Java was released 30 years ago, and short after its release, it has been ranking amongst the top most used programming languages, having today the largest community in software development with more than 7 million developers. They use Java for things like enterprise systems, such as enterprise resource planning or customer relationship management, cloud-native architectures powering microservices that are agile, scalable, and fault-tolerant, big data analytics platform like Hadoop and Spark, which provide insights at scale to business, and Android development, where Java's legacy as the foundation for mobile application continues, even though Kotlin has grown in popularity in the last years. So why is Java still so dominant? Because it maintains 3 qualities that are essential for modern systems. First, platform independence. Remember the slogan, write once, run anywhere? This still matters in globalized distributed systems. Second, scalability. Java powers systems that can handle millions of transactions daily. And third, security. Industries like finance and healthcare trust Java for applications requiring strict compliance and safety. So as you can see, Java is central to many of the technologies shaping how business innovate in 2025. But the story doesn't end with where Java is today. Java's growth over the past few years has been driven by 4 groundbreaking projects that are transforming its core DNA. These projects are making it even more suited for modern, high-demand applications. And those projects are, first, the Project Loom. The Project Loom introduces virtual threads, making concurrency far lighter and simpler for developers. Instead of dealing with the complexity of traditional threading, which is resource-heavy, Loom offers lightweight threads that allow high scalability with minimal performance overhead. Imagine a server handling thousands or even millions of simultaneous requests. Loom makes that seamless. The project Panama. Panama bridges the gap between Java and native libraries that could be written in C or other high-performance languages. These allow developers to scale applications while tapping into the power of native systems. This is especially impactful for areas like machine learning and data-intensive applications where speed is critical. Project Valhalla. Valhalla focuses on introducing value types, a new kind of data structure that is cheaper to create and faster to process. So instead of the heavy cost of objects, value types make large-scale data processing far more efficient. Valhalla is a game changer for industries like finance and gaming that increasingly depend on real-time calculations. Lastly, GraalVM. GraalVM led Java developers compile their code into native binaries. This run blazingly fast while being lighter and more resource efficient. GraalVM is also multi-language, meaning Java can integrate seamlessly with other languages, for example, Python or JavaScript, in diverse development environments. This is redefining what Java can achieve in high-performance systems. These 4 projects, Loom, Panama, Valhalla, and GraalVM, are not just technical upgrades. They are turning Java into a language fit for the demands of AI, cloud-native systems, and edge computing in 2025 and beyond. Java has a long history of adapting to major shifts in the software landscape. Before the rise of serverless, Java applications were typically designed for long-running monolithic servers. This made them less suitable for the short-lived, event-driven nature of serverless computing. So, to address this, the Java ecosystems introduced innovations like GraalVM and Project Leiden. This significantly improved the startup times and reduced memory usage. New frameworks like Quarkus and Micronaut emerged, and those frameworks, are especially optimized for cloud-native and serverless workloads. As a result, Java today is now a viable and efficient choice for serverless platforms like AWS Lambda and Azure Functions, just to mention some of them. This evolution demonstrates Java's ability to adapt and thrive through major technological changes. Now, let's connect Java evolution to one of the most exciting areas of technology, artificial intelligence. Many people often ask, what role does Java play in the AI space, especially compared to a language like Python? Well, here's a quote that summarizes the difference perfectly. Python trains the models, Java takes them to the real world. Why does this make sense? Today, Python is the preferred language for research, experimentation, and model development in AI. We have libraries like TensorFlow, PyTorch, and scikit-learn that make it incredibly flexible for training machine learning models. And not only that, also building neural networks and handling data science workflows. But that's just the first step. When those models need to be deployed in secure and production-ready systems, especially in certain industries like healthcare, finance, or other heavily regulated industries, Java becomes the clear choice. Just to give you some examples, in finance, AI models detecting fraudulent transactions are integrated into Java-based core banking systems. In healthcare, models assistance in patient diagnosis are deployed in Java applications that meet strict compliance standards. And in enterprise systems, Java ensures AI models are scalable across distributed environments and compatible with high-volume workloads. This partnership between Python and Java, trained with one, scaled with the other, ensures organizations can innovate responsibly while maintaining reliability and operational excellence. To sum it up, by 2025, Java is not only a legacy programming language, but also a forward-looking platform that is pivotal to some of the world's most advanced technologies, including AI, cloud-native architectures, and other emerging technologies. Organizations depend on Java because of its versatility, security, and scalability. And its evolution only makes Java ready to meet the demands of the next decade. Okay, so now that we have established where Java stands today, let's explore the force that's reshaping our entire industry, generative AI. We're not talking here about another development tool or framework update. We're witnessing a fundamental shift in how software is conceived. Before we dive in, I would like to ask you, do you think AI will impact Java development? I will try to answer that question during this section. So let's dive into how Gen AI is reshaping the tools, workflows, and roles in software engineering. And let me start with a striking example of just how capable AI has become. This graph here shows AI performance on GPQA Diamond. This GPQA Diamond test is a set of PhD level science questions that requires deep reasoning and expert knowledge. And what you are seeing here is remarkable. We have moved from AI systems that could barely handle basic questions near July 2023 to models that can handle PhD level scientific problems with increasing accuracy as of today, just nearly 2 years later. But here's what this means for software development. If AI today can reason through complex scientific problems, it can certainly understand code architecture, debug complex problems, and suggest optimizations that will take human developers hours to identify. This isn't about replacing human expertise. It's about augmenting it. When AI can operate at this level of reasoning, it becomes a true partner, especially in the development process, and not another sophisticated autocomplete tool. The implications for Java development are profound. We're talking about AI that can understand enterprise architecture patterns, suggest performance optimizations, and even help with complex refactoring across large code bases. Now, let's look at the trends driving this AI revolution. I have 4 metrics that tell the story of unprecedented technological acceleration. First, training compute is doubling every 5.3 months since 2020. If you analyze this is in Moore's law. This is exponential growth on steroids. The computational power being thrown at AI training is growing at a rate we have never seen in computing history. Second, algorithmic improvements are equally dramatic. The physical compute required to achieve a given performance in language models is declining at a rate of 3 times per year. What this means is that we're getting better results with less hardware. And efficiency is improving as fast as raw power. But here is the reality check, and this is crucial for enterprise planning. The cost of training frontier models has grown by 3.5 times per year since 2020. We're talking about a cost that has gone from millions to hundreds of millions of dollars for cutting-edge models. And fourth, the acquisition cost of training hardware has grown by 2.5 times per year since 2016. The specialized chips needed for AI training are becoming exponentially more expensive. But what does all of this mean for Java developers and enterprises? Well, the good news is that AI capabilities are advancing and increasingly speed. And efficiency improvements mean you don't need the latest, most expensive model to get significant value. The companies building these frontier models OpenAI, Anthropic, Google, and others are already making massive investments that individual enterprises can match. But you don't really need to. You can leverage their investments through APIs and fine-tuned models. For software development specifically, this means we'll see increasingly sophisticated coded assistants. But the real value will come from models fine-tuned for enterprise Java patterns and not necessarily the biggest, most expensive models. Well, throughout history, technological revolutions have fundamentally changed how we work and create. As an example, the Industrial Revolution introduced mechanization to manufacturing. This replaced manual labor with machines. And this shift didn't just make factories more efficient. It created entirely new industries, transformed economies, and required workers to learn new skills to operate and maintain the new machinery. A direct example from that era is the introduction of the assembly line. Before its invention, products were crafted by hand, one at a time. The assembly line automated repetitive tasks, allowing workers to focus on specialized roles and dramatically increasing output. This not only improved productivity, but also made complex products like automobiles more accessible to everyone. Compared to today, we're witnessing a similar transformation in software development with the rise of GenAI. Just as the assembly line that was used to automate physical tasks, GenAI is automating knowledge work. Developers now have access to tools that can generate code, refactor existing code, and even design entire software architectures. Those tasks that once took hours or days can now be accomplished in minutes, freeing up developers to focus on higher level problem solving and innovation. Both revolutions share a common thread. They drive efficiency, reshape job roles, and open up new possibilities. The Industrial Revolution redefined manufacturing, and now GenAI is redefining software development. As we adapt to those changes, we're challenged to learn new skills, rethink traditional workflows, and embrace the opportunities that automation brings. Ultimately, just as mechanization empowers workers to build more and build better, GenAI is empowering developers to create faster, smarter, and with greater impact than ever before. So, how are developers actually using GenAI today? Let me break this down into 4 key areas where we're seeing real impact. First, code generation. This is probably the most visible use case. Developers are using AI to generate boilerplate code, create method implementations, or even scaffold entire classes. In Java development, this means generating Spring Boot controllers, JPA entities, and unit test templates in seconds rather than minutes. Debugging has been transformed. AI can analyze stack traces, suggest root causes, and even propose fixes. I have seen developers paste complex Java exceptions into AI tools and get actionable debugging steps that would have taken hours of investigation. And let me digress for a moment here. A personal experience of mine, I was working in a previous project, maintaining legacy applications in a code base very complex with a lot of spaghetti code and bad practices that nobody really know how it worked. With the use of AI for debugging, we were able to reduce the average lead time of defects by a rate of 3. And as you can imagine, this is a game changer when you can achieve such results. Third, refactoring and optimization. This is where AI really shines. It can identify code smells, suggest design pattern improvements, and optimize performance bottlenecks. The AI can see patterns across thousands of files that would be impossible for a human to track manually. For documentation, perhaps the most universally appreciated use case. AI can generate Java doc comments, README files, and technical documentation that actually stays in sync with code changes. This means no more outdated documentation because updating it is now effortless. But here is the key insight. These aren't just separate tools. They are becoming integrated into our development workflows. We're talking about that the future isn't about switching between your IDE and an AI tool. It's about AI being embedded directly into your development environment. This is the landscape we're operating. AI capabilities are advancing exponentially. Costs are creating clear market dynamics, and developers are already integrating these tools into daily workflows. So the question actually isn't whether AI will impact Java development. It's how quickly Java developers can adapt and leverage that capabilities. Now, let's look ahead to the next years and explore how Java will evolve in this AI-driven landscape. I also have a question I would like to ask for this section, and is if AI will replace software developers in the next decade. Please share your thoughts in the QA session. Here, I want to share 5 key trends that will shape Java's future, backed with EPAM's latest research and some market analysis. First, the AI power revolution. According to EPAM's 2025 predictions, 30% of development teams will accelerate their SDLC using AI tools by the next year alone. But here is what's exciting for Java developers specifically. We are seeing purpose-built AI tools emerging. Take as an example the EPAM's AI Code Explorer tool. This performs deep semantic analysis of code bases in different languages, including Java, and converts source code into a navigable multi-level graph representation. However, let me share a critical insight from our research. AI will enhance but not replace developers. Why? Because coding only represents from 15 to 25% of the entire development lifecycle. So the real value lies in problem solving, architecture decisions, and understanding business requirements. And those things are uniquely human skills. So for software developers, you should think of AI as your intelligent pair programming partner and not your replacement. Second, we're entering the application generation era. Enterprise app generation platforms are maturing rapidly. And the major cloud providers, AWS, Microsoft Azure, and Google Cloud, are heavily investing in this space because they see the enterprise demand. This will fundamentally change how Java frameworks evolve. Spring, Quarkus, and other frameworks are already adapting to support AI-generated code patterns. So we'll see more opinionated frameworks that work seamlessly with AI generation tools. Now we can imagine describing a microservice in natural language and having a complete Spring Boot application generated for you. That's no longer science fiction. That's happening now. Again, the key question isn't whether this will happen, but how quickly Java developers will adapt to working alongside these generation tools. Third, platform consolidation, specifically in DevOps. My research shows that 50% of enterprises are moving away from best-of-breed tools change toward integrated platforms. This means standardization across build tools, testing frameworks, and deployment processes. So instead of managing Maven, Gradle, Jenkins, Docker, and Kubernetes separately, we'll see unified platforms that handle the entire Java application lifecycle. This consolidation will dramatically improve developer experience. This will make the onboarding times faster, reduce context switching, and will allow us to spend less time on tool chain management and do more of what is important, building great software. Fourth, the programming language landscape is shifting. Rust is climbing toward the top 10 languages, driven by memory safety requirements. Meanwhile, C and C++ usage is declining in new projects. But here is why Java remains strategically positioned. Remember the pillars changing Java DNA? Project Loom brings virtual threads for better concurrency. Project Panama enabled seamless native integration. And the JVM continues innovating. But Java's real advantage isn't just technical, it's the ecosystem. Decades of enterprise libraries, proven scalability patterns, and the largest developer community in enterprise software. That's not easily replicated. So, looking toward 2030, here are my 3 key predictions. First, AI becomes the ultimate development accelerator, but the developers remain the architects and decision makers. Second, platform consolidation drives standardization. This will make Java development more streamlined and accessible. Third, Java maintains its enterprise dominance through continuous innovation and ecosystem strength. The future of Java isn't about competing with AI. It's about leveraging AI to build better software faster. And that future starts today. So, to sum up, the future of Java in the next decade looks both promising and dynamic, with ongoing enhancements and Java is well positioned to remain a leading language in the years to come. But the reality is that it's not about competing with AI. It's about leveraging it to build better software faster. Good. So now let's address the elephant in the room. While AI promises to revolutionize software development, the path isn't without significant challenges. Based on EPAM's extensive research and client work, I want to share the real obstacles we're facing and how to navigate them successfully. First, the reality check. AI isn't magic. According to industry data, 70% of AI project fails to meet expectations. Maybe you're wondering why. So let me share 3 critical issues we're seeing repeatedly. Hallucinations and errors. LLMs generate plausible sounding but factually incorrect code. In Java development, we have seen AI suggesting importing non-existing libraries. This creates a security vulnerability that attackers can exploit just by creating malicious packages with those made-up names. We have bias from training data. AI models reflect the biases in their training data, potentially generating discriminatory or problematic code patterns. And the black box problem. Even experts don't fully understand how these models produce results. This makes debug and accountability extremely challenging. So, what's the key insight from here? It's that all AI outputs must be verified, especially in critical systems. AI serves as a tool that can generate certain suggestions, but you are the ultimate responsible for the actions taken from these suggestions. We're navigating a security and compliance minefield. Data leakage is real. When you send proprietary Java code to external LLM vendors, you are potentially exposing intellectual property and violating security regulations. We are seeing new attack vectors. Now, we have things like prompt injections that can circumvent security filters. Also, model poisoning can corrupt AI behavior. And there is the constant risk of intellectual property infringement from training data. Regulatory complexity is exploding. AI native applications must comply with GDPR, HIPAA, and other regulations. So now bias monitoring and compliance automation is becoming more critical. This is why EPAM developed private fine-tuned models that keep your data secure while providing contextually aware suggestions. So the idea here is to maintain the control while delivering value. Technical debt and integration challenges. So legacy systems compatibility is a major hurdle. Many AI tools don't play well with the existing enterprise infrastructure, and this is creating technical disruptions. Code quality issues are common. Generative code often requires significant refactoring to fix non-existing methods, remove redundant logic, and align with business requirements. And sometimes it's not worth it to pay off the cost of using an AI tool when you can be faster just doing it alone. The skill gaps are widening. There is a critical shortage of developers who really understand both traditional software engineering and AI integration. And complexity is exploding. AI native applications are exponentially more complex than traditional software due to advanced architecture, massive datasets, and the need to manage model-driven bias. And we still have the human factor that is often overlooked but critically important. First, the skill degradation risk. We're noticing an over-reliance on AI tools that could lead to developers not thinking as deeply. And this is problematic because deeper thinking remains the key differentiator between AI and humans. There are also, in certain occasions, team resistance. Team resistance to change creates adoption barriers. This will increase the cost and the need for comprehensive training and just compound the challenges. And governance gaps. Governance gaps are emerging. We're seeing agent sprawl, fragmented AI ecosystems that are difficult to monitor and control. This also increases the security risk without a proper oversight. Deep thinking remains the key differentiator between AI and humans. So, how do we mitigate these challenges? Well, EPAM has developed a comprehensive approach. Our AI Factory Risk Management Framework. This is based on PMI standards, but adapted to AI's unique risk. It provides systematic risk identification and mitigation. The security-first architecture with private LLMs, comprehensive threat modeling, and built-in compliance controls. We should ensure also a responsible AI by design that ensure fairness, interpretability, and safety from the start, and not as an afterthought. And of course, continuous monitoring. We have some real problems that should be constantly monitoring, specifically model drift, performance degradation, and some security threats. Here is the fundamental truth. AI in software development isn't just about adopting new tools. It's about rethinking how we build software systems, how we secure applications, how we govern development processes, and how we manage technical risk. Success requires proper preparation, the right frameworks and methodologies, commitment to responsible implementation, and continuous learning and adaptation. The key is to navigate these challenges proactively and not react to the problems after they occur. So let me leave you with 5 key takeaways for challenge navigation. First, verify everything. AI outputs must be validated, especially in critical systems. Second, security first. Use private or local models and comprehensive threat modeling. Third, manage complexity. Prepare for exponentially more complex systems. Fourth, invest in people. Address skill gaps and change management proactively. And fifth, govern properly. Prevent agent sprawl with proper oversight. The challenges are real, but they are manageable. We should only follow the right approach. And remember, success comes from preparations and not from reaction. So based on my research and real world experience, I see 3 pillars that will determine success in the Java 2030 landscape. First pillar is embrace AI as enhancement. The future belongs to developers who leverage AI tools to amplify their capabilities, and not to those who see AI as competition. AI can handle the routine, and you will handle the creative and strategic decisions. Second, master the fundamentals. Deep thinking, problem solving, and architectural decision making remains uniquely human skills. As AI handles more coding tasks, these skills become more valuable, not less, because that is what differentiates us from AI. The developers who thrive will be those who can think at a higher level of abstraction. Third pillar is navigate responsibly. Success requires security-first approaches, ethical AI implementation, and proper governance. The organizations that get this right will have sustainable competitive advantages. And those that don't will face compliance issues, security breaches, and technical debt that could cripple their entire development capabilities. Now, let me paint a picture of what success looks like in Java 2030. Developers spend 80% of their time on creative problem solving and architectural decisions, while AI handles routine coding tasks. Java applications are built faster, with fewer bugs, and with built-in security and compliance features. Enterprise development teams deliver business value at unprecedented speed, while maintaining the reliability and scalability that Java is known for. Java remains the backbone of enterprise software, not despite AI, but because of how well it integrates with AI-enhanced development workflows. The future of Java development isn't about choosing between human skills and AI capabilities. It's about combining them. Now, you have the opportunity to shape how AI enhances how AI enhances Java development. You have the chance to lead the transformation in your organization and build the applications of tomorrow. Now the tools are emerging, the frameworks are being built, and the future is being written. So make sure you're part of writing it. This is Java 2030. Thank you.
Thank you very much for your talk. Yeah, I was I need some time to bring microphone here. So thank you very much. I would like to highlight the topic which you brought during your talk, that Python is great for creating and training AI, and Java will bring it to the world. So that's really great. I think this is the thing which we should always keep in our heads, that Java is really great for integration and bringing things to the world. So we have a question. Yeah. So thanks for the presentation, Andres. There is a view that current LLMs perform best when solving problems that follow known patterns or combination of patterns, and struggle when no established pattern exists. Some argue this may reflect a fundamental limitation of the current architecture or scaling approach, given the pace of progress. How do you see this evolving? Are we approaching the limits of what current LLM architectures can achieve, or is there still significant room for breakthrough in solving problems without known patterns?
Oh, sorry, I didn't follow up. The question was pretty long.
Sure. So let me try to make it shorter. So LLMs are great to solve the problems with known patterns or combination of known patterns, but quite bad to solve problems where they need to figure something out from scratch, like without any patterns. So the question here is that, given the pace of progress and given how fast LLMs are progressing, do you see this problem to be solved soon, or are we approaching the limits of current LLM architecture, and to solve these problems we need to do something else, we as humanity?
Okay, yeah, now I got it. Thank you. Good. Well, I think it's a bit difficult because I will need to try to predict the future, and this is more like a personal opinion. As I was saying, what remains unique human skills are those strategic decisions, are that ability of solve that complex problem that hasn't been solved before, right? And that's where LLMs are not too good. Those new that didn't about. So I think in the near future that will still remain us, the humans, unique, and the LLMs will not, will be able to solve this in the near future. But when I am looking back and seeing how AI is progressing, how rapidly, how in just 2 years we're having models with the ability to solve PhD level scientific questions, that makes me wonder if probably in the near future, we'll have LLMs that could tackle also those problems with new patterns. I think definitely we will get to that point where LLMs will be definitely get better solving those new patterns, those new problems. But I think at least for now, no.
Okay. Okay, thank you very much for the answer and a lot of feedbacks. The talk is excellent and thank you very much for it. I don't see any more questions, so I want to say thank you very much. Thanks for being part of Java On and thanks for this amazing talk. Thank you very much.
Thank you all. I appreciate you having me, and I was pretty excited to share this topic with you all, guys.
Thank you. Bye.
Thank you. Bye.
So guys, that's basically it. Java On 2025 comes to its end. I want to thank you all for being today with us. And to finalize this wonderful day, let me just share with you one more time what we had today. And just to have it here with us. So this was Java On 2025. And today we have two communities which presented this conference for you. It's Jacob and Minik. Huge kudos to these communities. And also we have our wonderful sponsors and partners. It's Wear Community Platform, EPAM, of course, JetBrains, and Binary Brains community. Thanks to them a lot for helping. Also, we have wonderful set of our friend communities who help us with spreading the information and inform the world about our conference. Thank you guys very much. Happy to have you on board. Also, of course, let me show you one more time these wonderful faces. This is a team who brought you this conference. Thanks very, very much to all of them for their hard work. For last half a year, we preparing this conference. So yeah, amazing people, amazing team. I'm proud to be part of it. Thanks to them very much, and of course, thanks to our speakers who were here today with us. And also there are some offline events still happening. So some of them are today, and some of them will be tomorrow. So you still can check. If you're a EPAMer and you are in location somewhere nearby, you can jump in the train. And that was Java On 2025. With this, we finalizing, and all which is left to say that my name is Roman Mierson. I'm Java On host for this year. Thank you very much for being with us. Don't forget to rate speakers. Don't forget to watch the recordings and leave us the feedback. This is very important. So thank you very much. Have a great rest of the day and see you next year. Bye.